is it just me, or is there an increasing number of those 15-hour-long tutorials where you spend more time building than actually understanding what you wanted to learn? Today, we're gonna end that by building a crypto screener app with a built-in high-frequency terminal and dashboard. It's powered by the CoinGecko API, handling the most volatile data on the planet in real time. Using it, you'll build a homepage that highlights live discovery of trending assets and categories driven by real-time market momentum, a global explorer coin feed featuring a comprehensive all coins view with rankings, prices, and efficient server-side pagination, an analytics deep dive for each asset where you use CoinGecko's WebSocket API, enabling real-time sub-second candlestick charts, on-chain trades, and price updates through persistent data stream connections with built-in ping pong and auto reconnect, and a global command palette that replaces traditional menus with Control or Command K interface for instant market-wide search. We aren't just vibe coding, we're engineering. And because of that, by the end of this video, you'll understand how to fetch large datasets on the server while keeping the client lightweight, how to run parallel data requests without blocking the UI, how to combine server-side data fetching with client-side revalidation and real-time UI freshness, how to use streaming and suspense so pages render progressively as data arrives, how to manage complex flows with server actions cleanly and predictably, how to build custom hooks and a common reusable fetcher function for cleaner and more maintainable data, how to create reusable, advanced UI components that scale across the app while keeping it fast and responsive under heavy data load. Finally, you'll learn how to use the WebSocket API to display live streaming data and update the UI in real time, all while thinking about performance, scalability, and architecture in real Next.js apps. Once you learn these, you'll be able to work on any Next.js application comfortably. And alongside Next, you'll also use TypeScript, Tailwind CSS, ShatCN, Charts, and CoinGecko API, the most trusted platform for crypto data, and my go-to crypto data API for building Web3 and crypto projects. You can build almost everything in this project on their free demo plan with up to 10,000 API calls per month, but I'll also teach you how to use CoinGecko's API Analyst plan for those instantaneous WebSocket updates. You can use the JS Mastery 10 code for a discount on a paid plan if you decide to go for it. The link is in the description. So if you're a beginner to intermediate developer who wants to learn how to build real Next.js applications from a Figma UI and an API, this video will give you everything you need. And if you itch to build something more advanced, like full serverless, full stack development with Next.js, you can check out my Ultimate Next.js course and complete testing course for production level learning. The link is in the description. Go grab your coffee and let's ship this. Let's start developing CoinPulse by creating a new Next.js application. In this course, you'll learn how to structure a modern app using App Router and build reusable UIs with ShatCN. So let's get started by spinning up a new Next.js application. I'll start by opening WebStorm and creating a new project. I'll create it as a new empty project and call it CoinPulse. We'll create a Git repo manually later on, and I'll set it to TypeScript. So let's create. This will create a new folder, and if it's not empty, you can clean it up and open up your integrated terminal. Within it, you can paste the command we just copied, npx create next app add latest, and then add // to create it in the current repository, and press enter. It'll ask you whether you want to install the create next app installer, so say why, yes. And then you'll be asked a couple of questions. Do you want to use the recommended settings, including TypeScript, ESLint, Tailwind CSS, and App Router? And to that, we'll say absolutely, these are all the tools that we need to build modern, scalable applications. So press enter. And within a couple of seconds, Next.js installer will install only 3 primary dependencies, Next, React, and React DOM, and a couple of additional dev dependencies needed to improve our developer experience. As for the recommended options that we chose, the reason why we chose them is that TypeScript gives you stronger safety and better developer experience The app router is the current Next.js standard for layouts and streaming, and Tailwind CSS will help us keep our styles scalable without heavy CSS files. Once it's installed, you can simply run npm run dev to spin it up on localhost 3000. Then, back within the browser, you'll be able to see a Next.js boilerplate that looks something like this. Now, before we start editing the files, I want to quickly go over the capabilities of the IDE that I'll be using throughout the rest of the build. And you can too. It's WebStorm, and as of recently, it became completely free for non-commercial use, which means that you can now use it to develop your projects. So click the link down in the description and download it to be able to follow along and see exactly what I'm seeing. Another reason why I love using WebStorm is that you can pair it with Junie. Junie is a coding agent developed by JetBrains that makes you that much more productive. Throughout this course, you'll see me use Junie a couple of times, sometimes when I get stuck, or sometimes when I just need an extra push to develop the code faster. You can also download it right now so that later on we can just use it together. With that in mind, let me give you a quick tour of the generated file and folder structure. We'll spend most of our time within the app folder. Here, every route will be a folder, and every folder can have pages, layouts, and more. Currently, we have only one page, which is the home page. Then there's the layout, within which we set up our fonts and our site metadata. Here, we can also define that our page will be rendered in a dark mode, for example, because whatever you do here will be applied across the entire site. Then there's the globals.css, which acts as the Tailwind CSS v4 entry point, because we're importing Tailwind and setting up our theme. And the public folder, we have our assets. Then there's the next config, where we can create our Next.js configuration for image domains, experimental flags, build settings, and so on. There's also a package.json for all of our scripts and dependencies, package lock to keep track of those changes, as well as a tsconfig for TypeScript-related settings. Now, let's set up ShatCN. Open up your terminal, and thankfully WebStorm allows me to have multiple terminals running, so I will rename this to app, and then I'll create a new one, which I'll simply call terminal, and within it, I will run npx shatcn at latest init, which will ask me a question whether I want to install the shatcn installer, and then it'll ask me a couple of questions on the styles that I chose, such as the color that I would like to use. In this case, we can go with neutral. And to just verify if it's working, we can head back over to our app, page.dsx, remove everything from there, and simply type RAFCE, which is short for React Arrow Function with Export Component. And if this didn't work for you, you might need to head over to plugins or extensions, and then search for React Snippets. In this case, I'm using modern React snippets, and they allow me to quickly spin up new components. Within here, we can simply return a p tag that'll have a class name of text-3xl and text-indigo 500. This will change the color and make the text large, and I'll make it say CoinPulse. If you've done that properly and head back, you should be able to see a purplish, large CoinPulse text right on your homepage. Let's also open up our layout and modify the metadata of our application. I'll simply call it CoinPulse, and within the description, we can type something along the lines of crypto screener app with a built-in high-frequency terminal and dashboard. So now if you go back, you should be able to see that the title of your application changed, and very soon we'll also change the favicon to match the one of the final website, which you and I will build together very, very soon. And now that we've successfully set up our application, it makes sense to create a new GitHub repo for it, so we can consistently, from the get-go, commit and track our changes. I'll call it CoinPulse and simply click Create Repo. Next, we can follow the steps to get it committed. And this might be a good idea to put our browser side by side with our editor. That'll look something like this. So now within the terminal, we can follow the steps to get it committed. I'll first say git init, git add dot to add all the changes, git commit -m, first commit, git branch m to create and check out to the new main branch, add a remote origin, which will connect the local version of this repo to this one on GitHub, and finally git push u origin main, which will push the code that we have created right over here to our GitHub repo. You should do this at the start of every single project. because sharing your work makes all the difference. Potential employers, clients, companies, and other developers can find you like this and check out your work. Not only this allows you to keep track of your commit history and show everybody that you're the one actually doing those refactors, but it also allows you to include CodeRabbit right from the start. Nowadays, I don't create any projects without it because I like to move fast, but still, I don't want things to break. So I always set it up from the start, and then later on, whenever I make some important changes, I open up a pull request and let CodeRabbit review them. I'll show you how you can do that too later on. For now, you can just click the link down in the description, click try it for free, and then create your account using GitHub. As soon as it loads your workspace, you'll be able to see all the other repositories that I added or connected. And then you can also click the add repository button to add the current repo that we'll be committing your code to. With that in mind, now that the setup and the boring part is done, let's move from turning this into something that looks more like this. In this lesson, we'll start by developing our simple navigation bar. So back within our code, let's create a new branch for it by running git checkout -b feat as in a new feature we're adding, and then navigation. This will create as well as check out to this new branch. Now, let's start by understanding our design a bit better. I haven't just coded this out from my head. Instead, our designer prepared a complete crypto platform design. I'll share it with you for free within the video kit link down in the description. That way, you can explore it, see how it works, and maybe even download some icons, such as this CoinGecko logo that we've created, as well as some other icons that we have right here. What you can also do is pay attention to the color scheme. So if you click on the dashboard or on a specific part, you'll be able to see the color that we used for the background as well as for the text. The whole app is dark. We have the white text for the primary text color, but also the secondary text color right here. And then, of course, there's this green color that you'll often see popping up. Now, the goal is to take a couple of these primary colors and put them within our globals.css, which will act as the theme for our application. You can see the theme that ShadCN created already, but we don't need none of that, so you can remove it. And instead, click the video kit link down below, find CryptoPulse, and right below here, you can find the snippets that I've prepared for you. So simply copy the globals.css and paste it right here. It might seem like a lot, but most of it is just setting the theme, as well as specifying some helper utility classes that we'll use later on throughout the application, such as the containers, badges, headers, and so on. The main goal of this app is to help you understand Next.js features, like streaming and data fetching, not Tailwind CSS. If you want to learn Tailwind, I've already created a full video on it. I'll leave it linked down in the description so you can check it out if you're not comfortable with it yet. Still, of course, I'll explain the styles as we go. I just won't be writing them myself. Let me show you what I mean. We'll create our first component of the day. So right here within the root of our application, create a new folder and call it components. Within components, create a new file called header.tsx. You can see that WebStorm automatically asks me whether I want to add it to Git. I'll say don't ask again, and for now we don't need to add it. We'll do that manually. Within it, you can run rafce to quickly spin up a new header component. And then we want to import that header within our layout because the header will be showing on every single screen. So we want to display it right here above the children by simply referring to the header component, which will also auto-import it from components header. And another important change we have to make within our layout is to apply a class name set to dark to the entire HTML website. If you do that, you'll notice that the background will immediately turn over to dark mode. Now head over to the header and let's get it implemented. I'll start by turning this into a semantic HTML5 header tag. Within the header, we'll define a div that'll have a class name set to main-container. And it'll also have a class name of inner. Now, this is not a main ShadCN class name, but the one that I created before. So to be able to see what it actually means, you can search your code base for main container, and you'll find this layer components main container, where we're applying a padding Y of 6 to give it some vertical space, I'm also making it more responsive for medium devices and small devices, giving it some max width and some spacing. Now within it, we can render a link component coming from next link. That'll have an href pointing to /, which is typically the homepage. And within it, we want to display our logo. So I will import the image component coming from next image with a source of /assets /logo.svg and an alt tag of CoinPulse logo. Finally, we'll give it a width of about 132 and a height of about 40 pixels. If you save it, you'll see that we cannot yet find the CoinPulse logo. So the way you can get it is by going over to the Figma design, clicking a few times right here until you get to the logo, and export it in SVG. You can actually grab the whole part, not just the image, but actually the entire frame containing the word CoinPulse. Alongside exporting that, I'll also export this little icon right here, which is going to be used for our currency converter. So go ahead and click until you get to the image, and then export it right here, also as an SVG. Once you export both, you can head over to your public folder and delete all the files that are within it, and simply drag and drop the two new icons that you downloaded. One is going to be the logo, and the second one is going to be the exchange icon, which you can rename to converter.svg. Now, if you do that, you can just remove the assets part of the logo because the logo is directly within the public folder and it'll show up. Nice. Now we no longer need this CoinPulse text right here. Rather, we can return an empty div for now. Now back within our header, let's continue with the main part of our navigation. Still within the same div, I'll create a new nav tag, within which I'll create a new link. This link will have an href pointing to /. Yep, it'll still be the homepage, and it'll simply say home. Then below it, I'll do a p tag that'll say search modal, which will be a trigger for opening the search modal. We'll work on that soon. And then also another link that'll have an href pointing to /coins, which will open up the research page for all of the tokens. So we can say all coins. Now we have to figure out which one is currently active. And to be able to do that, we have to use browser's URL functionalities. But Next.js pages by default are server-side rendered, which means that they don't have access to the URL. So if you want to use the functionality, something like const path name is equal to use path name coming from Next navigation, you also have to add a use client directive at the top to turn this into a client-side rendered component. Now that we have it, we can head over into each one of these links, such as this one pointing to the home, and open up a new class name. Within it, I'll use CN, which is short for class names, which allows us to put dynamic links. It'll always have a class name of nav link, but then dynamically, we can apply the isActive class name only if path name is set to the /. And I'll also apply the isHome class name, which will be set to true in this case. So now you can see that on the smaller devices, it won't be here, but if we go larger, it'll be there. We can do the same thing for the coins page. So I will simply copy this class name and paste it to the coins link. But this time, isActive will be true only when we're on the coins page. There we go. Of course, if you click to it now, you'll see a 404, but you can see that it is active when we're on that page. And when we're on home, you can see that this one is white. And with that, we've implemented our first very simple navigation component. Not a lot of logic is happening here, but hey, step by step, we'll get there. This concludes our navigation feature, and with that, also the navigation branch. So if you open up your terminal, we can now commit the changes that we've implemented by running git add dot git commit -m, and I'll say implement navigation and run git push. Since this is the first push on the new branch, we'll have to copy and paste this set upstream method. Once that is done, you'll see that our navigation branch had recent changes 13 seconds ago. So even though this is a super small example, it is a perfect opportunity for me to show you how the rest of the workflow of this great application will look like. We open up a branch, start developing the features. Once they're done, we compare and open up the pull request, create that pull request, and if you added CodeRabbit to this repo, it'll very quickly start preparing the report for you. In this case, it has just one to do, to find more bugs. So you need to give it a minute. I think in this case, since it's a super small PR, it might take just a couple of seconds. And immediately you'll get a walkthrough of the changes that were implemented. And once again, you should always start reviewing those changes from the start so new bugs don't sneak in. And I'm glad that we have a super simple example to show you how all of this works. In this case, we're simply introducing a new header component with navigation, integrating it into the main layout with dark mode styling, expanding the global CSS with comprehensive color variables and UI component styles. And we simplify the homepage to an empty div. We see the summary of changes per file or per cohort of files. You get the estimated code review time. In this case, it's moderate because this globals.css does contain quite a few class names. And then we have a simple header. In this case, I'm assuming we won't get any major bugs, but a couple of nitpicky comments, such as these ones. But would you look at that? There is one huge potential issue. And it says that for assets in the public folder, Next.js expects an absolute path starting with a /. So using just logo.svg may cause a 404 or resolve incorrectly depending on the current route. Okay, this is actually huge. It then gives you a proposed fix, so we can fix it. In this case, it cannot be any simpler, but rather just adding a simple character. And then it also provides you with a committable suggestion in case you want to do it right away. But if it's a bit of a more complex fix and you want to run it by somebody else, it also gives you a prompt for an AI agent to fix. In this case, it might feel really silly to try that out because we only have to add one character. Come on, we're not that lazy. So back within the code, I'll head over into our header.tsx and I will add a starting /. Then I will simply run git add dot, git commit, and say fix CodeRabbit suggestion and git push. As soon as you push, this PR should update. The code should be rechecked, but in this case, I believe we're more than safe to merge this pull request and continue developing the other features of our application, all of which are going to be about crypto market data. In this lesson, we'll set up the CoinGecko API so it's easier to develop the UI alongside displaying the real data. CoinGecko is my go-to source for crypto market data, and it's been a trusted standard in the space since 2014, and they're kindly sponsoring this video. So besides learning Next.js, using this API, you'll also learn how to develop tools, dashboards, and screening monitors to discover market insights, track trends, and understand how real-world crypto data is analyzed in production applications. You can start using CoinGecko by heading over to API pricing. Then, if you want to try it out before subscribing, you can create a free account, and you'll be able to develop so many of the functionalities from this application entirely with a free account. You get 10,000 calls a month with a rate limit of 30 per minute. I'll show you how to make the most of the demo API, but also later in the project, I'll show you how to use the analyst plan that'll give you access to 10 WebSockets, which we'll use to build a real-world crypto screener focusing on real-time data. For now, go ahead and start with a demo account by clicking Create Free Account right here. I'll leave the link down in the description. And then simply join in with Google or Apple. To create your API key, simply click your profile and then Developer's Dashboard. And here you can add a new key. You can give it a label, such as CoinGecko, and click Create. Then you can simply copy it and add it within your application, specifically within a new file that we'll create in the root of our application that I'll call .env.local. So here we can create a new CoinGecko _API _key, which will be equal to the key you just copied. We'll also duplicate this and allow it publicly, so we can access it from a next public endpoint, which will give it access on the client side as well. Finally, also define the CoinGecko base URL by making it equal to https://pro-api.coingecko.com/API/v3. We'll use this later on. And now that you have your own CoinGecko API key, we can turn this into this. So immediately in the next lesson, let's dive right into implementing our homepage. Now that we've got the API key, you can head over to your app, page, and we can get started developing it. We'll first develop the layout. So I'll turn this div into a main tag and give it a class name set to main container. Then within it, I'll create a new section, and that section will have a class name set to home grid. So we can create the grid of our homepage. Within it, we can start creating the layout by creating a couple of different p tags. We'll have our coin overview, which is going to show the main information about the coin. Then we'll have another p tag that'll show all of the trending coins. And finally, below this section, we'll create another section that'll have a class name set to wfull. So this one is going to take the full width of the screen with a margin top of 7 to divide it from the previous section and a space y of 4 in between the elements. And this one will render the name of the category that's going to be, well, categories. So it'll show different categories of cryptocurrencies. So now on small devices, you can see they all show up one below another. But if you go to a desktop screen, you'll see that the coin overview and trending coins will show one next to another, whereas the categories will take the full width of the screen exactly like it does on the final application. Now we can create the UI for the coin overview by removing a p tag and turning it into a div that'll have an ID of coin overview. Then within it, we can display another div that'll have a class name set to header. Within the header, we can display an image. And for the source, for now, we'll make it static, but later on, we'll make it dynamic depending on which coin we're checking out. So right here, the source will point to https://assets.coingecko.com/coins/images/1 large bitcoin.png. So for now, we're going to obviously display Bitcoin's logo. So that's exactly what I'll type right here. And you'll get an error saying that you cannot yet display this image right here. That's because within our next config, we have to allow the assets.coingecko.com endpoint to be able to display images. So simply say images, remote patterns, and then within it, add one that has a protocol of HTTPS, and it has the host name set to assets.coingecko.com. If you do this and add a width and a height to this image, such as 56 and 56, you'll be able to see a Bitcoin logo appear right here. Then right below it, let's also render another div that'll have a class name set to info. And within it, we can display a p tag that'll say the full name of the coin, such as Bitcoin, and then BTC, which is the ticker, and then an H1, which is going to render the current price of Bitcoin. At the time of the recording, it is about 89K. So I'll set it right here. And we can also give this div a class name of header, but alongside it, a padding top of 2 to make it look good. And that's it for the primary coin display. Later on, below this Bitcoin, let's spell it properly, we'll display an entire chart which will be updated in real time, allowing you to choose the period as well as the update frequency. But for now, let's move on to developing the trending coins. Throughout this application, there's going to be so many different tables. We're going to have one here, one there, and there's going to be another one in all coins. That means that it makes sense to take some time and really try to approach the data table component in a way that it's reusable and that it looks good on all the different places where it's used. That way, we'll avoid writing the same boilerplate code over and over again. So first, let's install a table component coming from ShatCN UI. We can install it by running this command right here. That is npx shatcn add latest add table. Once we add it, we can create a new component for it within the components folder, where I'll create a new file and call it data table.tsx. And within it, we can follow the steps needed to recreate a ShatCN table, and then we'll modify it to our use case. First, I'll copy all the imports, then run rafce and then copy the actual usage of the table right here. What you can do then is simply import it within your page. So right here below trending coins, I will import the data table coming from our application. And if you get back, you'll be able to see this demo table coming from ChatCN. This table right now just displays one table, so if we reuse it on a second page, it'll still show the same data. We have to somehow extract that data, and we need to be able to pass it into the component to show different data depending on where it's getting called. That means that we'll have to pass all the new columns, the data to fill in those columns, the row key, which is a function to generate a unique key for each row, an optional table class name in case we want to style it differently, a header row class name, a header cell class name, a body row class name, and finally a body cell class name. Now, since we're defining all of these different props, first of all, they have to be within curly braces as we're destructuring them from props. And then we have to define the type of all of these properties. So something like defining that columns is going to be maybe an array. Then data is going to be an array of different objects. And then we have to define the types of all of these properties. So instead of writing it all right here, what you can do is create a new file called type.d.ts within the root of the application. This is a special file. And D stands for declaration, which means that we'll declare all of our types right here. Within it, you can start defining different interfaces. Interfaces are simply object-like types. So interface, you can call it data table props. And within it, you can, for example, say that the table class name is optional and of a type string. And then you have to repeat this for all of the other class names. And then you'll be able to declare all of these types directly by referring to the prop. So data table props like this. Of course, right now it doesn't know about all of these other ones because we haven't yet declared them. So just so you don't have to write all of these types yourself, I have actually gone ahead and provided them for you within the video kit link down in the description. So under snippets, you can find types.d.ts and simply copy and paste them here. There, you'll see the data table props containing the data table column, the data itself, row key, and all of the other class names. If needed, occasionally I'll go back to this file and explain exactly how I came to these types. One thing that we also have to do is make this data table accept an additional type that we're then passing over into the data table props. Now in this case, we also have to pass an additional prop called T into the data table props. You can do that like this, define it here and here. Now this file and our entire application knows exactly what type of columns is going to be, the format of the data, the row key, which we have to spell properly, same thing for the body row class name, and now we can use them across our application. If you want me to do a fully typed version where we write all the types from scratch, just let me know down in the comments below, and we'll do a proper TypeScript crash course. Now with that in mind, let's turn this basic table into a table that's fully reusable. First, I'll give it a class name, set to CN, so we can pass multiple class names into it. The first one will be custom scroll bar, so that we give it that hint of green. Don't forget to import CN coming from libutils. And we can also pass this new class name that we'll create called table class name. In this case, we can skip the table caption, but for the table header, we can simply provide a new class name of header class name. And I think we actually missed this one when defining all the props that we'll need to pass. Then right beneath the header, we have the row. So let's give a new class name to this row of CN. On hover, we want to change the cover to transparent. So I'll say BG transparent exclamation mark. And then we'll also apply the header row class name. Within it, you can see that currently we're displaying a couple of different table heads, such as the invoice, status, method, and the amount. In this case, we'll want to map over all the columns that will dynamically pass over through props. So let's remove these table heads And instead, let's map over the columns by saying columns.map, where we get each individual column and its index. And for each one, we automatically return a table head that will then render the column.header information. So when we're calling the data table, specifically right now that is within our homepage, we'll have to pass in the columns data, and for now I'll set it to an empty array. Later on, we'll fill it with the real data. This table header needs to have a key since we're mapping over it, and that's gonna be an index for now, and a class name set to, we'll do a CN, so we can provide multiple class names. We'll provide a BG dark of 400, text dash purple of 100, padding Y of 4. Only the first element will have a padding left of 5, and the last element will have a padding right of 5 as well. You cannot see those yet because our column headers are empty. But if I go back here and provide a header for our first column to something like, let's do a title of the coin, you can see how this is gonna look like. And then we can duplicate it and provide a second one, which is gonna be maybe the price of the coin. And you can see how that's going to look like right here. Then, right below the table row for the table headers, we can go down and focus on the table body. Within here, we'll map over the data by saying data.map, get each row and its index, and for each one, we can automatically return a table row. Each table row will also map over the columns, so I'll say columns.map, where we'll display a table cell. Each table cell will then render its contents. By saying column.cell, we'll pass over the data for the row and the row index. This row index is coming from here. Of course, data doesn't yet exist, so very soon when we get the real data coming from this table, we'll also need to pass alongside the columns the data to fill in those columns, which is also going to be an array. Then, since we're mapping over our table rows, let's provide a key to each one. And to make it super unique, we'll pass it into this row key function where you pass the row and the row index. Then we can give it a class name set to CN, and we'll pass some class names like overflow hidden, rounded-LG, border-B, so we can see the differentiation between each row, border-purple-100 over 5. On hover, we'll change it to background dark 400 over 30. And it's very important to make it relative. That way it's tracking your cursor and you can actually see as you're hovering over different rows. After all of these class names, I'll also provide the body row class name. This one is going to be unique depending on what we pass in the props. And finally, we'll do a similar thing for the columns. I'll rename this I to column index, and we'll provide this table cell a key of column index, as well as a class name of CN, and then we can pass a padding Y of 4 to create some vertical spacing. We'll give to the first element a padding left of 5, and to the last of padding right of 5. This is going to make so much more sense once you actually see it on the screen. So now that we have this, what seems to be a reusable table, we can head back over to our homepage and actually put it to use. We'll need to create a format for the data that we need to pass into this table. So let's do it right here above the page, const columns of a type data table column, which will take in the trending coin coming from types, specifically an array. It'll be equal to an array where each specific column will contain a header. For example, the first one will be the name of the coin. Then it'll contain the cell class name that'll be set to name-cell, and it'll contain the cell information itself, which in this case will be set to a function where we accept the information about the coin. And then let's actually put this into multiple lines so it's easier to see. Once we get it, we want to extract that item that we're displaying. So that's going to be coin.item. And then we want to return, in this case, not just a title saying the coin name, but rather we'll link to the details page of that coin. So we'll have a complete link coming from next link, with an href of /coins /item.id. Of course, we have to turn this into a dynamic template string, just like this. And then within this link, we can render an image with a source of item.large. An alt tag can be the name of that coin. So that's going to be item.name, a width of about 36, a height of 36 as well. So far, we have no data to display, but trust me, it'll appear right here soon. And finally, below the image, we can render the actual name of that coin. So that's going to be within a p tag, where we're going to render the item.name. Now we can go below this cell right here, and we can add another column. This one will have a header of 24-hour change. So how did the price move in those 24 hours? And finally, what will display within that cell? We'll get the information about the coin, and then we'll open up a function block within which we can extract that item from coin.item once we actually fill it with data, and we'll figure out whether it's trending up or down. So const is trending up is equal to item.data.price underscore change underscore percentage underscore 24 hours.usd. And if it's greater than 0, that means that it is trending up. Finally, that gives us the info to return a div displaying the corresponding change. So I'll give it a class name of CN, and it'll say price change. So that's going to be the general class name. But within the CN, if it's trending up, then it'll have a class name of text-green 500, else it'll have a class of text-red 500. And don't forget to import CN because we're now in a different file. Within it, we can display a p tag, within which, if it is trending up, in that case, we'll display an icon coming from Lucid React. So let's install that package. It's maybe the most popular icons package on NPM. It's called Lucid React. And once you install it, you can just start typing trending up and simply import it from Lucid React. We can give it a width of about 16, as well as a height of 16 as well. And likewise, I'll duplicate it. Now we want to see what's going to happen if it's trending down. In that case, we can just say trending down and import that icon from Lucid React. Of course, this import has to come all the way at the top, trending up and trending down. Let's make sure to properly close it. And again, we have no data yet, but we'll have it very soon. Just one more header to show, and that header is the price. So another object with a header called price, a cell class name of price cell, and then a cell itself, which gathers the information about a coin and automatically returns the price of coin.item.data.price. This one is a bit simpler than the others, right? Okay, great. So now is the time that we feed some kind of data into the table to be able to see it. We're going to gather tons of data from the CoinGecko API, which means that we'll create a reusable fetcher function in a new file to fetch everything in a super simple way. But before we dive into implementing that, I still want to see how this table would look like with some fake data, just until the real data comes in. And this is one of those cases where AI can help you in a matter of seconds. In this case, I'll be using Junie. So if you haven't yet installed it, click the link down in the description and just install it and open it up. And once it's there, let's tell it something like review app page.tsx and add a local dummy trending coin array dataset matching the trending coin type. So you'll be able to use our TypeScript types to define that dataset. Use existing local image assets for thumb and large, so images resolve. Wire the dummy data into the data table so the table renders rows. I think if you stop and retype this into Junie, it should be able to create some kind of a data set for us. Let's see how well it does. It looks like it's understanding what we're doing, so it's updating its own task progress. The objective is to add dummy data to the data table. It managed to find the file and update it. There we go. It's editing the page as we speak right now, adding the dummy trending coins such as Bitcoin and Ethereum in this case. And it should also be able to automatically put them into the table. There we go. It added the dummy trending coins with the columns, the row key, and the table class name. Wonderful. So if I collapse this right now, would you look at that? We can already see the data within the table. Under name, it shows Bitcoin, and it looks like it used the CoinPuter logo as the logo instead of the actual Bitcoin logo, which is totally fine for now. We're going to replace this later on once we get the real data. And then it's also displaying the 24-hour change, whether it's trending up or down. Wait, is it just me, or did Junie just fix this part as well? Because here, before, I don't think I used the absolute value and to fixed percentage. I believe we just had it written like this, which is not as precise. So this is definitely better. So now that we have the homepage that looks like this, but still displays dummy data, it deserves to get the real data fetched from the CoinGecko API. So in the next lesson, let's build a fetcher function that'll allow us to do just that. In this lesson, we'll start fetching real data and display it on our homepage. And we'll do that with CoinGecko's demo API. I'll leave all the relevant links down in the description, but in a nutshell, this demo API allows you to call many different endpoints, everything from a simple ping to checking the prices of coins, as well as listing all of the supported coins and their markets. There's a lot of stuff to explore, so let's dive right into it. First things first, I'll install an additional package that'll help us with creating different URLs. npmi query-string. It'll allow us to stringify URLs. Then we can create a new file within the lib folder. It'll be called coingecko.actions.ts. This will be a server file, so we can use the use server directive because it's only going to be called from the server. And within here, we'll implement all the data fetching logic for all the different CoinGecko API endpoints. I'll also import QS from query string, so we can stringify our URLs later on. And let's also get access to our CoinGecko base URL by saying const base URL is equal to, and we already stored it in our process.env under CoinGecko _base _URL. We can just check it to verify. It is CoinGecko base URL, and we need to do the same thing with the CoinGecko API key. So I'll duplicate this, go to the process.env CoinGecko API key, and I'll rename this to API key. If we don't have access to the base URL, that means that we cannot do anything. So let's immediately throw a new error saying couldn't get a base URL. And I'll duplicate that and do the same thing with the API key. If there is no API key, could not get API key. Perfect. So this will save us in case we cannot properly get it from environment variables. And now we can focus on the most important function of this file, the one that's going to be responsible for fetching all of the different endpoints. I'll export it, so export async function, and I'll call it fetcher. And I'll define this new dynamic type that will pass into it of t, depending on what we're fetching, and it'll take in a couple of parameters. It'll take in the endpoint that we're trying to fetch of a type string. It'll also take the params that are going to help us fetch specific things. These are going to be optional and of a type query params. And finally, we want to revalidate it. So I'll say revalidate to 60 seconds in case we don't revalidate it sooner. Finally, this function will return a promise because we're making an asynchronous call, and then we can open it up right here. So first things first, we have to figure out which URL we're trying to call. It's not just as simple as defining the URL and making it equal to the base URL. We have to construct the URL. So that's where we're using this QS, as in query string, where we can stringify a URL by connecting together different parts. First, we pass the URL object that contains the URL itself, which is going to be a concatenation of the base URL and the endpoint that we're trying to call. And then to it, we can also append additional queries, which are going to be params. So essentially, we're constructing this CoinGecko starter part and appending the endpoint like coins as well, and potentially passing some additional params like, I don't know, the ID of our account or the API key equal to the API key. I'll show you how we're going to connect it all very soon. And we can also pass an additional options object right here that's going to say skip empty string and set it to true so that we don't have to manually remove the parameter keys if we pass empty values, as well as skip null values set to true. Perfect. Now we have to make a call to this URL. And for that, we'll use a regular fetch object. So I'll say const response is equal to await, fetch the URL, and then we're going to fetch it, but at the same time, we're going to pass a few headers. We need these headers to be able to make a valid request, such as xcg pro API key, which we're going to set equal to the API key that we got from the CoinGecko API, and then also the content type, which we'll set to application JSON, as that's how APIs most commonly communicate. Now, I'll define the type of these headers. It'll be a record of a string and string pair. Finally, we can define the next object in the response, and we'll pass in the revalidate in case we want to revalidate the response in a specific amount of time. Finally, we have to check if the response went okay. So if it's not an okay response, in that case, we can extract some kind of an error body, which is going to be of a type CoinGecko error body equal to await response.json. And then on this response.json, we can also chain a .catch that looks like this and then returns some information. Finally, we can throw a new error that'll say API error, and it'll include the response.status, so we know what happened, as well as error body.error, or if that doesn't exist, it can also include the response.status text. So this way we for sure get something back. And finally, if the response is okay, we're going to return the response.json. So what we're doing here is creating an abstraction that allows us to much more easily make every single endpoint call later throughout the application. So for now, we want to implement the first one, the one that's going to fetch the data for Bitcoin, what we already got the dummy data for. To do that, we can head over to the CoinGecko API reference for the demo API, and here you can check how to fetch the coin data by ID. This endpoint allows you to query all the metadata, including the images, websites, descriptions, address, and market data as well, such as the price, all-time high, exchange tickers, and more. The only thing we have to do is call the /coins/ID. So if you press the try it button right here, you'll see how the request will work. You have to feed it with your API key. Thankfully, we have ours. We have already stored it in our application. So I'll simply copy it and paste it right here. And then you have to pass the coin ID. In this case, we can go with Bitcoin. As soon as you do that, you'll see that we get back this kind of an information. An object containing the ID, the symbol, the name, the web slug, and much more information about Bitcoin, even how it's called in different languages. This is pretty cool, but what I care about is the price. So you can see here the market data and the current price in all the different currencies in the world. This is amazing. And yeah, it contains a lot of data. So now we want to implement it within our code. I'll head back over here. And since we've built a fetcher, we can actually just make a simple call directly within our homepage, which is where we need to actually call the data. So right here on the home, I'll turn this page into an asynchronous page so we can await calls right here. And then I'll say const coin is equal to await. We're going to import the fetcher that we have created in our CoinGecko actions. We'll define the type that we're expecting this to return. So it's going to be the coin details data. And what are we doing here with TypeScript? Well, if you remember, in the fetcher function, we defined that we're going to pass a specific type T, and when this function is resolved, it'll return that T type. So since fetcher will call different API endpoints, like an API endpoint for coin details, but maybe sometimes it's going to be the entire coin list, or it's going to be market, or all the different data, we cannot yet know to define it at this time. We have to define the type at the time when we call the fetcher. And that's in this case returning the coin details data, which is exactly what you've seen from the CoinGecko demo API directly in their playground. So now we know that this coin will actually contain the coin details data, which is going to be the ID, name, symbol, and so on. So if we try to do something that doesn't exist, like coin.test, we'll immediately know that test doesn't exist on coin data details. But if we try to do something like coin.id, you'll see that this one is okay, and it's of a type string. That's the beauty of TypeScript. Now, the endpoint for this one is going to be /coins/Bitcoin. And we also need to pass an additional options object right here of dex_pair_format, which I'll set to symbol. What this does is it allows us to return back a simple human-readable token symbol, like for example, BTC for Bitcoin, instead of the entire address. Okay, and now that we have done this, you see that we're getting an error. And that's good, because that means that our fetcher error handling is working, telling us that we got a 401 unauthorized. And that's being thrown directly from this line right here in the fetcher. That immediately makes me think that we have an issue with our API key, or in the way that we set our API key. Yep, right here, we should have put CG as CoinGecko, not CH. And as soon as you do that, you can see that the error is gone. And for the request, we get back a 200. So the only thing we have to do now is properly use the data of the coin that we're getting right here. So right in the header, we can remove this image right here, at least remove the static declaration of it, and say that the source is equal to coin.image.large. The alt tag will be set to coin.name. Then for the name of the coin, we can set it to coin.name / coin.symbol.to uppercase. And then finally the price, which is under coin.marketdata.current_price.usd. I knew it's going to be here because I tried it before within the CoinGecko playground. Now, as soon as you do this, you'll see that we're going to get an invalid source prop because CoinGecko images are not yet supported under our next config. So copy this host name and head over to our next config, which is right here. And then on top of the assets CoinGecko, go ahead and add another one. That's going to be the host name of coin-images.coingecko.com. If you do that, it'll be able to properly pull the image from CoinGecko. And now we can go back to our homepage. We can also format the price in a bit of a better way. Again, AI tools are perfect for this. So I'll just select it, press Command-Shift-P and open up Junie. And I'll tell it to create a utility functions within the utils file that'll properly format a number in a currency format and then apply it within homepage. And I'll even paste this part where we're using it. Let's see how well it does. So I need to update a currency formatting utility. Okay, it already edited utils.ts and it updated the homepage, the price seller. Oh, I can see a change right here on the homepage immediately. And that's it. Check this out. So it created the format currency function within our utils file, which is right here within the lib. And then it imported it at the top, format currency. And then it even used it by wrapping this price right here. And now we have commas, the $sign, and everything else. Wonderful. Now on the same page, we also want to fetch the trending coins. So we can display them right here. We can do that with the trending search list API endpoint, which is also a part of the demo API. It allows you to query trending search coins, NFTs, and categories on CoinGecko in the latest 24 hours. So to try it, the only thing you need is a demo API key, and you get back the data. We can implement it very easily by making another fetcher call right here. Const trending coins is equal to await. We use the same fetcher utility function, and then we pass the type of what we're expecting to get back. In this case, we're expecting to get back coins, which is going to be an array of trending coin type. And specifically, we're making a call to /search/trending. For the second parameter, which are the options, we can pass undefined because we don't have any parameters. But then we have the revalidate key, which we can set to 300. Now, think about what's wrong here. What you've built is exactly how most developers and even AI would approach this. It's correct, readable, and works just fine. You would now be able to map over these coins and display them on the homepage. But when you think about performance, scalability, and user experience, this pattern can cause problems as your app grows. And let me break down why. In modern web development, speed isn't just about how fast your code runs. It's about when your users see the content. When building apps with Next.js and React Server components, it's easy to accidentally create something known as a waterfall, which is a common architectural bottleneck that slows down your application. A waterfall happens when data requests are executed one after another, rather than simultaneously. In a standard asynchronous function, if you have one await call in front of the other, it's going to wait for it. So the coin data is fetched first, and then only after it resolves, the trending coin starts fetching the data, and then it gives the response. If each request is a couple hundred milliseconds, then the users will definitely notice. So what's the solution? Well, the quickest way to break a waterfall is to trigger requests in parallel using a promise all. This tells JavaScript to fire off all requests at once and then wait for the group to complete. The advantage is that it's significantly faster than the waterfall, as both of these requests happen at the same time. But the limitation is that while it's faster, it's still a blocking operation. The server will not stream in any HTML to the client until the entire promise all has resolved. If one request is slow, it holds the entire page hostage. Not good. So finally, there's Suspense. Suspense is a revolutionary way of handling asynchronous dependencies. Instead of waiting for the data to be ready before rendering the page, Suspense allows you to render the page in chunks. You can deliver the static parts of your page, like your navigation, layout, sidebars, immediately, while you stream in the data that comes in as soon as it does. How does that work? Well, you have to wrap your data fetching component, in this case the homepage, directly within something known as a suspense boundary. Then you have to provide a fallback, which is usually a skeleton, like a demo version of that page, without the data, and then you have to send the data to it. So think of this as a mini masterclass on streaming as well, and let me show you how it works. Right within our components folder, I'll create another folder, and I'll call it home. Within home, I'll create a new file called coinoverview.tsx, and simply initialize it using RAFCE. Then to it, copy and paste the fetcher for the coin details. This is going to be it, coin, and paste it right here at the top. Of course, make this one asynchronous as well, and also move the part that actually uses that data. That's going to be this div that says coin overview. Thankfully, it has a nicely descriptive class name. So you take it from here, you move it into here, and you return it as its own component. Similarly, we want to create another component for the trending coins part. So also within home, create a new component, call it trending coins.tsx, run RAFCE, and then also copy the fetcher part that we have added within our homepage, const trending coins. We can now remove these ones from the home and simply paste them in the trending coins at the top. Then we have to do the same thing with the JSX. So grab the declaration of how a table is supposed to look like, these columns right here. You can just copy them and remove the dummy trending coins for now. And then just move that part over to the trending coins. We can add them right here at the top below where we fetch the coins. Don't forget to also make this one asynchronous. And finally, paste the part where we actually display the trending coins. That's going to be this one, a p tag that says trending coins, and then a div that actually covers them, but not including the category section. So just the inner part. Once you do that, you can paste it right here, and you'll see that our homepage has gotten pretty empty. Oh, and since we pasted this, we also have to wrap it in a React fragment, because we cannot have two adjacent properties, one next to another. and we can use this trending coins data and pass it as the data. But you can see that my indentation is not that good because we did a lot of copy pasting. And for that, I think it makes sense to set up prettier and ESLint. I don't like doing those manually, so I'll call Junie to help me. And I'll say set up ESLint and prettier within this project. So let's see how well it does. It's going to open up package.json, check whether we have it already, and potentially create some ESLint configuration and prettier configuration files. It can even run terminal commands for you to check how is your installation looking. There we go. It's going to run the lint command and then format it. And take a look at this. It's going to fix some errors, and maybe you'll have to do it a couple of times. It even removed the unused import statements and additional stuff that wasn't necessary. And there we go. It did it. Now I just think I have to enable it on save. So I will search for ESLint right here within the settings. I'll turn on the manual configuration and detect it directly from my project and point to the configuration file, which is right here within the CoinPulse. And I'll repeat the same thing with prettier. So it's going to be a manual configuration pointing to prettier, and we will run it on save. So now if you make some changes or indentations or anything like that, and then you press save, it'll format it automatically for you. Wonderful. So now we have these trending coins right here, but we have unfortunately cleaned up our homepage entirely, so it's not showing any data. But we did clean it up a bit because now we have separated the concerns. Each one is fetching its own thing. It looks like we have one warning right here within our trending coins. Let's actually make this a div with an ID of trending-coins and render this as an h4, trending coins. Now, it looks like data is complaining about the format that we're receiving these trending coins in. So what I'll do is I'll say trending coins.coins.slice, and we'll only get the first 6, or pass an empty array in case we cannot fetch them. And now we can actually put them to use back within our homepage, which is now much cleaner. It doesn't have anything. So first things first, we're starting with the home grid. And within the home grid, we'll use this suspense thing coming from React. Suspenses need fallbacks, as I explained. So fallback for now can simply be a keyword of loading within a div. And then once it loads, we want to show the coin overview. Then we want to duplicate this right below. And instead of rendering the coins, now we're going to render the trending coins. Here we can say loading trending. And here we can say loading overview. And now if you save it, you'll see that basically they load instantly. But if it actually did take some time for them to load, oh, there we go. You saw it for like a millisecond. It said loading something. And we can also style this trending coin stable a bit better by giving it a header cell class name of padding y of 3, like this, as well as a body cell class name, which is going to be set to a padding y of 2, like this. So check this out. First of all, it looks a bit weird because here we have to display our full chart. But bear with me. Both of these two containers render their own data. And if you open up inspect element, head over to network and turn on a slower network, not even super slow, but like fast 4G, and you do a hard reload, maybe we have to go a bit slower, like a slow 4G, or maybe even slower, like 3G, because this is super fast, you can see that they still load pretty much instantly, even if we disable the cache. But having this fallback of loading is a bit weird because you can see this flashing text, right, if I keep repeating, and then it falls into place. And this messes with browser's cumulative shift because it breaks the layout while it's loading. So we have to add a proper fallback to both of these components. I think this is another one of those opportunities where AI tools like Junie can really shine. I'll open it up. And we can tell it something along the lines of create a, let's call it fallback.tsx file with coin overview fallback and trending coins fallback, skeleton UIs that match the existing, and now I'll refer to the class names that I have in the CSS, which is going to be hash coin dash overview fallback and hash trending coins fallback, CSS rules, using data table for the trending table layout. And then we also wanted to update the page.tsx to use these components as suspense fallbacks. I think I was super precise. I think it would have been able to do it even if I was less precise, but let's see just how well it does. So it's gonna get the structure of the project, check out the CSS, and then it'll start creating the skeletons within the file that we told it to do it within. There we go. It understood the task. It's gonna check the structure, immediately create a component that acts as the fallback element. So now it should actually, oh wait, it did it. So if I reload, check this out. I keep pressing reload, and as it's reloading, we can see that we have empty skeleton containers for where the data is supposed to be as soon as it loads, so that nothing on the screen shifts. And then as soon as I stop pressing my keyboard like a maniac, we immediately see the data stream in right where it should be. So let's see exactly how we've done that. Basically, within Suspense, we have added these fallbacks that are basically just empty divs with some styling that replicate the structure but not data of the website. And again, if you go to a super slow network, I'm not even sure if we'll be able to notice this given just how quick CoinGecko's APIs are. But if we disable cache and go to 3G and reload, yep, you can see how fast that was. And I'm going to switch it to something like a 4G for the images to stream in as well. Beautiful. This is already amazing. We're utilizing 2 different endpoints from CoinGecko API, and even though we still have this huge empty space in the middle, which we'll implement in the next lesson once we add our Candlestick Chart, we first want to push this over to GitHub to do a bit of a recap of what we've done and see if we have made any errors on the way. So to do that, I'll head back to the terminal and I'll run git status to check which branch we're on. And it looks like we are still on the feed navigation branch, which is fine for now. We could have used better naming for implementing the homepage, but for now, I'll do a push and then we can open up a PR. So git add, git commit -m, and we're gonna say implement coin overview and trending coins UI and functionality using the fetcher utility function. And git push. Now back on our GitHub repo, you'll see that the feed navigation had recent pushes. So let's go ahead and compare them with the main by creating a pull request. There we go. There's no conflicts, which we know because we're the only ones working in the project. But let's wait about a minute for CodeRabbit to check whether we have some bugs or inconsistencies. In this lesson, we've established a cryptocurrency dashboard foundation with tooling configuration with ESLint and Prettier, a server-side API integration layer for CoinGecko data, and a reusable table component architecture with homepage components, such as coin overview and trending coins. We have made the changes across all of these different files. This was quite a complex review because we've added a lot of code since the initial PR. So let's review CodeRabbit suggestions. We have a couple of nitpicky comments, such as the search modal currently being a placeholder. And it immediately tells us that it can create an issue to track the implementation of the search modal feature. This is amazing. We also have the utils where we can maybe shorthanded. In CoinGecko actions, instead of .catch, we can also add a .then. And this is a nice one. This is a redundancy where we use the slice or an empty array because slice always returns an array, never null or undefined. Okay, this is also a great way to learn new things and how they behave. But let's take a look at more important errors that we have right here. The first critical one comes from the coinoverview.tsx, where it's suggesting that we add error handling for the data fetching operations. This async fetch operation has no error handling, and if the API request fails, the error will propagate and crash the page render. We need to wrap it in a try and catch block or rely on an error boundary at a higher level. So it suggested a plan where we simply wrap it in a try and catch and then return a fail div if it doesn't work. I believe it's going to suggest the same thing for the trending coins. This is great, so we can actually use a prompt that they suggested to try this out. And back within the code, I'll just open up Junie, paste it in, and then I'll say also do the same thing for trending coins, because we know that the same issue is happening there. Now, while it's solving the issue, we can take a look at the other issues that we have right here, one of which is a duplicate ID. Okay, this is definitely an issue that we have right here with the trending coins. So let's head over into trending coins. And yeah, it looks like we have a duplicate ID. The table itself doesn't need to be within a div. When it comes to the catch, we don't have to close it right here, but rather it's enough to only wrap this part with try and catch, and we can extract this trending coins at the top. So if we do it like that, trending coins, then redeclare them right here, we can then use them later on without being afraid that something will break. And let's check out the changes that happened right here within the coin overview. While this is an interesting solution, I definitely prefer wrapping just the call itself within a try and catch block. So I will add it right here and end the return regularly. Of course, we have to extract the coin declaration above so that we can actually use it. Perfect. With that in mind, we just fixed a couple of very critical issues. So with that, let's push our changes by running git add dot, git commit -m, fix code rabbit critical issues, and git push. As soon as it recognizes the changes, we can go ahead and merge our PR. Perfect. The next lesson will be all about implementing this candlestick chart. So let's prepare ourselves for that by opening our terminal, checking out to the main branch to pull all the latest changes from the main branch, and then we can create and check out to a new branch by running git checkout -b feat candlestick chart. Perfect. That means that in the next lesson, we can start implementing it. In this lesson, we'll create a candlestick chart that shows how a coin is performing over a specific period of time. You can check out today's performance, drag it around and zoom it if you need to, or maybe check out how it performed over the last year. This is looking amazing. You can even increase or decrease the range as well as the date range as well. This is pretty cool. We'll start by installing TradingView's lightweight charts. So you can simply run npm install --save lightweight charts. In a matter of seconds, it's going to be installed and we can start using it. We can create a new component within the components folder and we can call it candlestick chart.tsx and run RAFCE. We'll reuse this chart whenever we need to show some kind of a market data. But since this is going to be used on the client side only and has to be rendered that way, we'll pass server components such as the coin overview as its children so you get the best of both worlds, keeping the other data server side rendered and only rendering the chart on the client side. Let me show you what I mean by that. First, I'll head over to our home coin overview component. Within it, we want to fetch some additional data alongside just fetching the coin data details. We'll use another one of CoinGecko's endpoints called the OHLC chart, open, high, low, close of a coin based on a particular coin ID. It'll give us all the data needed to create a chart. So we simply need to follow this endpoint. We can do it right here in the try block after getting the regular coin data. So I'll still call the fetcher. We'll define the type of the data we're trying to get, OHLC data, specifically an array of those data endpoints. And then we can go to coins, Bitcoin, OHLC. And then we can provide an object with additional options, such as the versus currency. We're going to do everything in USD. The days can be set to 1 by default. Interval can be set to hourly. And we can also decide which precision do we want to get. In this case, I'll go with the full precision. So here we're making another call and we're getting back the coin OHLC data. So I'll create a new variable for it. Let coin OHLC data like this. And then we can set it right here by awaiting our fetcher call. Now keep in mind, as before, we're calling these one after another, but instead we can call them in parallel as these two pieces of data don't depend on one another. So what we can do instead is use promise that all. So right here, I'll say const destructure the data, such as the coin and the coin OHLC data, and call it like this, await promise that all. And then into it, we simply need to pass the two functions like this. This is going to be the first one. And then the second one is going to be this one. That way, both of these are going to be happening at the same time. And only when both are done, it's going to fill in these variables with data. What we're doing here is declaring them. So there's no need to declare them above. So one thing that we can do if we want to directly use the data is we can put this return statement directly within this try block. So if it's successful, go ahead and return this data immediately. Else, return the coin overview fallback. And now the question is, how do we use this candlestick chart? As I told you, it has to be rendered on the client, but we want the rest of it to remain server-side rendered. So inside of the coin overview, we will call the candlestick chart. And by the way, if you're wondering why is it called a candlestick chart, if you check out the final version of the application and maybe zoom in a lot, you'll see that these seem like candles, but rather they show you the high and the low price that coin has reached during this specific period of time. For example, here, each candlestick shows 1 hour. And you can see that during this hour right here, the lowest price has been here and the highest has been here. It is red because it is lower than the previous price right here. So we have this chart and we're going to pass this part as children to the candlestick chart. I'll simply pass it right here. That way, it's not going to appear immediately, but when we pass the data to it, such as data is equal to coin OHLC data, and we pass the coin ID, in this case, Bitcoin, we can head over into the candlestick chart and implement it by giving this div an ID of candlestick chart. Within it, we can render another div that'll render the chart header. So it'll have a class name of chart-header. Within it, we can render a div with a class name set to flex-1. And here, we're going to render the children that we're passing over as props. So right here, we can destructure the children, as well as the additional data that we're passing over into the chart. So that's going to be children, data, the coin ID, maybe even the height of the chart that we want to display, which by default can be set to 360 pixels, and maybe the initial period, which by default we can set to daily. And this will be of a type candlestick chart props. Perfect. So now we can still see this overview, which loads nicely with the skeleton, but now we'll also be able to display a client-side rendered chart. So we can give this a use client directive. First, I'll start with creating the JSX for the chart. So still within the chart header, below the children, I'll render a div that'll have a class name set to button group. This one will keep track of different buttons for the periods that we want to manipulate our charts to show the data for. So I'll render a span that'll say period, and we can give it a class name set to text-sm, margin X of 2 to give it a bit of margin on left and right, font-medium, text-purple-100 over 50. I found this color to work great as it's not so much in your face. And then we actually want to show the buttons. These buttons are going to look something like this. Each one is going to be a button. It'll have a key. For example, this one will be for 1 hour. And then it'll have a class name, whether it's active or not. For now, I'll give it just a regular config button class name. It also has to have an onClick. So onClick will later on have to trigger the period change. And if we're loading the data for that specific period, we want to set it to disabled. So it'll be disabled if we're currently loading. And that loading will, of course, be a new state that we can create and track right at the top of this component. So I'll say use state, loading, set loading, and at the start, set to false. And within the button, we can say something like 1 hour. There we go. So now we can see the button for 1 hour, and we want to have multiple of these buttons. like 1 day, 1 week, and so on. But instead of duplicating it all here, we can create a constants file. This is a new file which we can create in the root of our application, inside of which we'll create all sorts of different constants that we can reuse across the application. So I'll create a new file called constants.ts, and inside of it, you can export a new constant called period buttons. Like this. We typically use uppercase letters and an underscore in between to denote that this will not change and is a constant. This will be an array where each button will have a value of something like daily and a label, which will be just 1D to keep it short. We can then duplicate this and make it weekly as well. And here we can say 1W. And now we could go ahead and add more of these. Within the constants file, you also want to add some data for the chart, like the colors, the height, the width, and so on. Just so we don't have to write these by hand, I'll provide them for you in the video kit down below. It's constants.ts. Just copy it and paste it right here. You'll see that we get our period buttons. So they go from daily all the way to yearly and then max. And we also have our period config, so we can track the period. Here, we also have some information for the chart, such as the background color, text, grid, and all of the colors to make it look good with the theme of our application. Now that we have created those buttons, we can simply map over them by creating a new dynamic block of code and saying period buttons dot map, where we get each individual button, from which we can destructure the value and the label. And for each one, we can automatically return the button like the one I've created right here. But instead of simply rendering 1 hour for every single button, it'll have a key set to the value, so it's unique, and it'll render its label. So now you can see 1D, 1 week, 1 month, 3 months, 6 months, 1 year, and max. Amazing. We also want to know which one is currently active. So to be able to track that, we can create a new function called handle period change right here at the top. Const handle period change is equal to a callback function that accepts a new period that you select when clicking on it of a type period, and it checks if new period is the same as the current period. In that case, we don't have to do anything. It's already set, but else we actually want to update it. And then here we can update it. We'll do that later on once we can actually visualize the chart. So I'll say update period. And that period will of course be another state that we can keep track of. So I'll say use state period, set period, and at the start set to the initial period, which is daily by default. And now let's also give it an active state. For example, by default, daily is selected. So under class names, we can say if period is triple equal to the value that is selected, in that case, we can render the config button active, else we'll render the config button. So now we can see that 1 day is selected, and we cannot change it yet, but we can at least try by calling the handle period change and passing the value that we want to change to. If you do that, and here, if you actually update the period, like set period to be equal to new period, you'll also be able to see that we can now swap the period, even though this doesn't mean absolutely anything yet, as we can't yet see the chart. So that is the next part that we have to implement. Right below all of these divs, below the final closing div, I'll render a self-closing div within which we're going to insert the chart. To be able to do that, we have to give it a reference. A ref equal to chart container ref, which we'll define above, a class name set to the chart, as well as a style that includes the height. So let's create this chart container ref just above. I'll do it at the top of the component. Const chart container ref is equal to use ref. We can even give it a type of HTML div element or null if it doesn't yet exist, and we'll pass in the null value at the start. Don't forget to import useRef from React so we can actually use it. And we'll also need a couple of other refs to be able to display the chart properly. First one is to the DOM element that will host the chart, but then we have a ref to store the chart instance across renders. So I'll create another one called const chart ref is equal to useRef of a type iChart API or null, and at the start set to null. This iChart API is coming directly from the package we installed, iChart API, and that's going to be a lightweight charts. And finally, we'll need a third ref to track the instance of the Candlestick series. So I'll say const candle series ref is equal to useRef I series API, like this. It's not uppercase. I made a mistake right here. It's just regular letters. That way it'll auto import it for you right here. And I series API, also coming from lightweight charts, specifically the type of the chart that is candlestick, like this, or null. So make sure to properly close it, properly type it, and at the start, it's equal to null. And now we have to refetch the data for the chart whenever the period changes. So let's create a new use state right here that we'll call OHLC data. That's the data for the chart, and set that data. The data will be of a type OHLC data, specifically an array of those data points, and it'll start as the data that we receive through props or just an empty array. That way we can initialize it as the data coming through props, but then if it changes, we can actually accommodate for those changes. We can do that by creating a new function, const fetch OHLC data, which is going to be equal to an asynchronous function that accepts a selected period of a type period, and then we can open up a new try and catch block. And here we can do something similar to what we've done when we initially fetched it right on the home page. Or rather, that's going to be within the home coin overview, where we fetch this data right here. So we'll simply copy the part where we initially fetched it and paste it right here in the try block. So what's happening here is we first have to get access to the selected period, but specifically we need to look into our constants where we have the period configuration. So we can simply say 1 day or 1 week. We have to provide both the days and the interval and the name of that specific config. So that's why I created this nice configuration object from which we can then extract the proper configuration structure. So we can say const config is equal to period config, and then into it or from it, we select the right period. Once we have the configuration, we can simply fetch the data by saying const new data is equal to await fetcher, same as before. This time it doesn't have to be Bitcoin. Rather, it's going to be whichever coin ID we're fetching the details for. So we're going to make this a template string. The currency versus is going to be USD, and days now it's going to be dynamic. It'll depend on config.days. And same thing right here, the interval will be coming from config.interval. You can shorten this a bit by automatically destructuring the days and the interval from the config, like this. And then you can just shorten this part. And if both key and the value are the same, you can just keep the former. So it'll look like this. Finally, if the data changes, we can say set OHLC data to be equal to new data, or if that doesn't exist, to an empty array, just so our app doesn't break. And in the catch block, I will console.error and say failed to fetch OHLC data and also render the error. Wonderful. Now, whenever we try to change the period, we can refetch the data. And in this case, we can also start something known as a transition. This is a new React hook called useTransition that transitions the state but keeps the UI responsive during async updates. To do that, you can do it right here. Const is pending, so the change of the period. And then instead of set pending, it gives you a start transition function where you can just use transition coming from React, make sure to import it. And then right here in handle period change, where we need to update the period, we can start the transition before we actually set the period. So I'll say start transition. It's going to be an async callback function within it. And then I'll set the period to be equal to new period. And at the same time, we'll fetch the data by saying await fetch OHLC data, and we'll pass in the new period that we want to fetch the data for. Finally, we have to create a use effect to take that data and to actually append it to the chart. We can do that with, as I said, a use effect. So I'll open up a new callback function within it. And as the dependency array, we'll only take the height of the chart. So if the height changes, we can properly reposition it. Now, the way you feed this data into the chart is you first get the container, which is going to be the chart container node. So you can say const chart container ref dot current. Then if there is no container, we simply exit out of the use effect. Else, we need to decide whether to show time labels based on the period. So I'll say const show time, and then it's going to be daily. We can also display weekly, and we can do monthly if it includes the period that we're choosing. And with that, we are ready to create the chart by saying const chart is equal to create chart coming from iChart API, to which we pass the container where to create it, and then some potential options, such as we can spread the get chart config, which you also have to import, and into it pass the height as well as the show time. And we can also provide the width set to the container.client width, so it takes the full width of the screen. If you reload now, you should be able to see something that looks like a container for a chart, but nothing within it just yet. So that means that now we have to add a series of candlesticks or a series of data points. So say const series is equal to chart.add series candlestick series, like this, and get candlestick config, like this. I'll actually collapse this a bit more so we can see the full code in one line. Once we do that, we have to convert and set the initial data into the series. This is where it starts getting exciting. So type series dot set data, and into it, we need to pass the OHLC data, like this. But the format that data is within is not going to work right off the bat. We have to make it work specifically for the chart. So if you head over into our utils, like libutils, we need to create a special function that'll make it work for the chart. I actually prepared a couple of functions that we'll use throughout the rest of this course, so you can find the complete utils.ts file in the video kit down below. Just copy it and paste it here. One of these is going to be the format price, which I believe we renamed to format currency, so make sure to fix that. And then you'll see that the other ones include the format percentage, trending classes, time ago, but more importantly, the convert OHLC data. To be honest, I created this with an AI agent, and it just makes sure to take the OHLC data that we're getting from CoinGecko, and it properly formats it into the data that the chart accepts. So now we can go here and we can wrap the data with the convert OHLC data function, just like this. And there we go. For the first time in our application, we are starting to see some real candlesticks data chart. The period is not going to change just yet, but the initial candlestick chart is right here. So what else do we need to do now? Well, you know how if I reload, it's not going to fit in immediately. It's going to feel a bit weird taking the right portion of the screen. So what we can do is say chart.timescale, and we can use the fit content function to make it fit initially in the whole screen of the chart. Now we can store this chart instance in ref for later updates or cleanups by saying chartref.current is equal to the chart we created. And we can do the same thing with the series. So candle series ref.current is equal to the series we just created and set up. Now, this is an interesting thing. We have to manually handle the observer. The observer is specifically for resizing. So I'll say new resize observer that takes in the resizing entries. And whenever something happens, it's going to also resize the chart. So I'll say if no entries.length, simply return. But if the width of the container changes, we also have to apply the change of the width to the chart. Right now, if I do that, you can notice that it stays the same. This is not good for a responsive application. So instead, what we can do is say chart.apply options, where we pass in the width, which is going to be equal to entries 0 dot content rect dot width. So it's going to dynamically see the change in the width. Now we have to use this observer by saying observer dot observe. And what are we observing the changes within? Well, the container that keeps track of the chart. So if I save this and reload, now if we try to drag and drop, notice how it takes the full width of the container, even when it switches to a desktop mode, where it actually has less width than it had here. Wonderful. Finally, we have to clean everything up at the end. So say return, a callback function, observer.disconnect, chart.remove. So we're destroying the chart instance to prevent memory leaks. And we want to do the same thing with the refs. Chart.ref.current is set to null, as well as candle series ref, we also set it to null. And finally, we have to make this chart work with different periods. To do that, we have to create another use effect, but this time it has to react on the OHLC data that we provide that will be modified depending on the period that we click on. So we want to check if there is no candle series ref right now. That means the chart hasn't even been initialized. In that case, we can't modify the data. But if the chart is there, in that case, we can say const converted to seconds is equal to OHLC data dot map, where we get each individual item of data. And for each one, we return an array where we can provide all the different data points that a candlestick needs. First is going to be math.floor of item 0 divided by 1000. The second one is going to be the open price of that item. So item 1. Then it's going to be the high price of the item, item 2. Then it's going to be the low price of that specific candle. And then it's going to be the close price of the candle. See, even though this candlestick chart seems like just a regular line chart, each one of these candlesticks contains so many more data points. Some are necessary for the color, some for the width and the height of the candle, and so on. So now that we have all of these data points, I'll say as OHLC data to make sure that TypeScript is happy. And once we have this data, we can say const converted is equal to convert OHLC data and pass in converted to seconds. Then we're going to re-update the candle series ref by saying candle series ref.current dot set data to converted data. And we want to update the chart to refit the content by saying chart ref.current question mark dot time scale, and finally dot fit content, same as what we've done before. Let's properly use this variable right here. Looks like converted to seconds is complaining a bit here, saying that this argument doesn't work here. Oh, that's because I have an array within an array. We only want to have one array that we're returning right here. So dot map and then map.floor and all these things within it. Perfect. TypeScript really saved us here. So if I reload the page now, you'll see that it looked good. But if I change it to 1 week, it'll actually update and give us more data while at the same time fitting on the screen. We can also change it to 1 month, 3 months, or 6 months. It's really cool because you get access to all of this data within the chart. And even if you're in a max period, you can still zoom in and manually get back only to, for example, the last month and really explore it in detail. So you can see that changing the periods actually works and resets the charts. It is still very active and you can move it. And most importantly, if you go to full screen and reload, you can see that now this chart actually takes more of the screen. The only little fix that we'll make later on is that the height of the coin overview container, including the chart, is the same as the height of the trending coins. so that way we don't see this empty space. We'll fix that later on. But now we can open up our terminal and run git status to see where we are. So we have actually modified the coin overview and the utils, as well as added this new candlestick chart directly on the new branch. So now that the chart is done, we are ready to push all of these changes and see whether we have some bugs. So I'll run git add dot, git commit -m, implement candlestick chart, and git push. We'll of course have to connect it to our upstream origin, press enter, and now we can open up a PR directly within our GitHub. Back within our repo, you'll see that we can compare and open up a pull request. So let's do just that. And let's wait for CodeRabbit to come up with a code review. And there we go. In just a couple of minutes, we got our update. There is one minor potential issue happening in our candlestick chart, and it says that the loading state is never updated. So we should use isPending instead. Yep, we created this useLoading before to disable the state of the button. So definitely the fix is to just replace this and use isPending instead. We can make that change in the code easily by heading over to our candlestick chart, removing the isLoading state right here, and instead using the isPending right here on the disabled prop of the button. There we go. One issue fixed. Now, in this case, we are adding only height as a dependency to the use effect, but it says that it uses OHLC data and period inside as well. This means that when OHLC data changes, the chart won't reinitialize. This is handled by the second use effect, so this is okay, but when the period changes, show time calculations uses stale period value. The period dependency is needed for the time-scaled visibility to update correctly. This is also a good fix, so I'll simply go ahead and add the period right here. There's also another major issue in the candlestick chart saying that there's inconsistent time conversion between initial mounts and updates. On initial mount, this convert OHLC data is called without converting milliseconds to seconds, but on data updates, we convert milliseconds to seconds before calling it. So the proposed fix is to also apply the same conversion in the first use effect. So let's go ahead and copy this part, head over into our first use effect, and before we pass this data, we can remove these plus and minus signs, convert it to seconds, and then pass in the data that is already converted. Perfect. That's another nice save. And finally, there is one minor one. It is in the coin overview, saying that we can remove the redundant await inside of promise alls. Yep, this is amazing. The fetcher function already returns a promise, so we no longer have to add a wait in front of it. So if I head over to the coin overview, we can just remove the await right here. And it looks like there's some kind of a warning right here saying that avoid constructing JSX within try and catch, and that instead we should use an error boundary. This is coming from ESLint, and we can look into this later on, but for now, I believe this is more than fine, because either way, we are returning some code. So even if it fails, the component will still return the data properly. Great. So with that in mind, we've made our changes. I'll do git add dot, git commit -m, implement fixes suggested by CodeRabbit, and then run git push. With that in mind, we are ready to merge this PR back to main. And then within the code, we can check out back to the main branch, which didn't yet have the chart at this point in time. But now, if we run git pull to pull the latest changes, you can see the chart and everything we just implemented. Wonderful. In the next lesson, let's scroll down and implement the categories part of our application, which looks like this. It'll show us different categories of cryptocurrencies and tokens and so on. For example, layer 1 tokens like Bitcoin, Ethereum, and so on, proof of work and proof of stake coins, coins made in USA, stable coins, and so on. So let's display this table next. To do that, I will first create a new branch by running git checkout -b, and we'll call it feet top categories. So let's dive right into it. To build this table of all the different categories, and let me actually expand it so you can see it a bit better, will be very similar to the approach that we used for the trending coins. You already know the flow. Fetch the data, create columns, and then match the styling and layout using data table. The goal here is to prove you can transfer the pattern to a new dataset and make it feel consistent with the rest of the homepage. Treat this as your chance to work independently, because you're not just learning new tools, you're strengthening your muscle memory by applying what you've already built. So let me help you a bit. And then if at one point you're ready to continue on your own, that's great. First, you need to create a new component within the components folder. It'll also be within the home folder, and you can call it categories.tsx. You can use RAFCE and very easily import it within our app. That's going to be right here. So instead of just the text that says categories, you can now render the actual categories component. Great. So back within our application, you should be able to see little categories right here. And don't forget that you can also wrap it in Suspense. So right here, create a Suspense with a fallback saying something like, let's do a p tag that says loading categories, ... and then within it, you render the categories component. And now the goal is to develop it. Head back over to the CoinGecko API, specifically the API reference for the demo version, and here you can find the categories. You can just search for it, categories right here, and specifically, we want to get the coin categories list with market data. It's this endpoint right here. This endpoint allows you to query all the coin categories with market data, market cap, volume, and so on. You can even try it to be able to see what kind of data you're getting back. Understanding what data you're working with is critical. So at the top, we can simply fetch the categories by making this an asynchronous function, and then using an await on our fetcher call. Thankfully, we have created that fetcher before, so it's going to make it easier for us to fetch the data. Specifically, we're expecting to get back an array of different categories, and we can get it under the URL of /coins/categories, exactly what we read in the docs. And now we have to structure that data in terms of columns, headers, and rows that we're going to display in the table. Const columns is equal to, it'll be of a type data table column, specifically of a type category like this. And then we're going to define that as an array where we're going to have a header that's going to have the name of category, a cell class name of category cell, and finally a cell itself within which we're going to get a category and will return the category dot name. So that is the first column that we have. Now we can try to display that table below by giving this div an ID of categories, a class name of custom scroll bar, so we can scroll through it if we're on a smaller device. I'll render an H4 within it that'll say top categories, and thankfully we can reuse the data table component we created before. To it, we have to pass the columns, which now we thankfully have. We can also pass the data, which we also have, so we'll take the categories and slice only the first 10 out of it. And we no longer have to say, give me the 10 or an empty array, because you know that CodeRabbit told us that whenever you use slice, if something goes wrong, it'll return the empty array for sure. And then for the row key, we can get the index out of it and just return it like this. Finally, close the data table. Let's actually make this take multiple lines so it's a bit easier to see what we have. We have columns, data, row key, and finally the table class name of a margin top of 3. So if you save this now, you'll be able to see that we have what seems to be an early version of the table. Top categories, the first column that displays the category names. But now we have to add other columns to the columns list. Columns for, well, let's see, what do we have? The icons of the top gainers, the 24-hour change, the market cap, and the volume. I would actually want you to try to implement this on your own. You'll know that each one of these columns has to have the following things: the header, the cell class name, which I've already prepared for you. So it's going to be the top gainers cell in this case, because this one will be all about top gainers. That is the second field that we're working on. And then finally, and most importantly, what will we display in that cell? you get all the data needed to display it right here within the first param, which is category. And then from it, you can actually extract the category image. So what you can do is console log the category, see what data you get back from it, or directly refer to the API, and then see that right here, you have something known as top 3 coins, and that gives you their images. So this is exactly what we need. So it's all about reading what the API gives you and putting it to use. So just to give you an example, it'll be category dot top 3 coins dot map, where you get each individual coin, and for each coin you render an image that has a source of coin, an alt of coin as well. It'll have a key of coin because it's unique, a width of about 28, and a height of 28 as well. So now if you save this and go back, you'll be able to see these top 3 gainers. But in this case, it looks like the styles are not getting applied because the top gainer cell should basically apply a flex container on it, which should make them appear one next to another, like within the final application. But here they're one on top of another. So that might mean that we haven't properly passed the cell class name into the data table. So back within the data table, we have to make sure that we have the table class name, then we have a header row class name, but there are some other class names that we have to provide. 1, 2, 3, 4, 5, 6. So let's actually copy all 6 of these and make sure that we have them right here as props. I'll also add commas and indent it properly. Yep, it looks like we're missing the header cell class name and the body cell class name. So let's provide these where they need to be. The header cell class name will be in the table head right here, where we have the class name. We're applying regular classes, and then right after the regulars, I'll apply the header cell class name, as well as if maybe it comes from the column, so column.head class name. And I'll do the similar thing right here for the columns, where we have our last BR5, and there we'll apply the body cell class name, as well as the column dot cell class name, if it's coming from the column. And now we can see that we're applying those styles that we are specifying right here in the column. And now there's 3 more additional columns that we have to implement. We have the market cap and the 24-hour volume, as well as the 24-hour change. Let's do the market cap and the 24-hour volume first. They're pretty simple once you understand where the data is coming from. So we need a header for the market cap. The cell class name will be market cap cell. And then the cell itself will simply get the data about the category, and we'll call the format price, or in this case, format currency, and pass in the category dot market cap into it. Just like that, we'll have to import the format currency from utils, and you can see the market cap. Now we can basically duplicate this below, and instead of market cap, we'll say 24-hour volume. It'll be a volume cell, and here we can basically provide a volume underscore 24. So here you can see the full amount of this coin in circulation, and here you can see how much it circulated over the last 24 hours. Now, doing the 24-hour change will be a bit trickier, but not too tricky. Again, we're going to start with the header that's going to say 24-hour change. Then you define the class name, which is going to be change header cell. And finally, you need to define the cell itself, which takes the category, and then from it extracts the market cap change in 24 hours. If you do that, you'll be able to see this number. But we have to turn it into a percentage point and maybe display an icon that goes up or down depending on what it is. We've already done something similar for the 24-hour change in trending coins. So if we head over into trending coins and notice this part where we have, there we go, this is it, the price change. We basically want to copy what we have here. So I'll basically copy the entire cell right here and just override this one that we created. Instead of the coin, here we're getting the category, but more or less everything should remain the same. From the category, we're checking whether it is trending up or down, and we can get that based off of the category market cap change in the last 24 hours. If it's greater than 0, then it's trending up. Then we create a div with a CN of change cell. And if it is trending up, we do a text green of 500, else we do a text red of 500. Finally, we display the icon as well as the actual market cap change, but we're going to do it in a bit of a cleaner way. At the bottom, I'll say format percentage and pass in the category dot market cap change in the last 24 hours. This format percentage has to be imported from utils, and here you can see all the numbers. It seems like everything is in the negative today across all the markets. And now, if you expand this, you'll be able to see your full table. Maybe we can make this 24-hour change arrow appear on the left or right of the number. We can do that by putting the price right here at the top and then giving this p tag a display of flex. So I'll do a class name of flex. There we go. You can see it here, and we can make it even by adding items dash center. And if you want to, we can do this for the trending coins as well. So I'll head over into the trending coins and simply modify this p tag to include the class name just like this. And here, now that we have the function for the formatting percentages, we can use that instead of this math. So I'll simply say format percentage, which of course we need to import, and then we don't have to use the to fixed and everything else. And we can shift it up. This is looking great. So now we not only have the trending coins, but we also have the top categories. So you can get a general overview of what's happening in the crypto markets. Now, if you've been paying attention, there is one thing that you might notice, and that is that for the top categories, we still haven't added a skeleton loader. So if you reload hard enough, you'll see that these ones will have the skeleton loader. So it seems like they load instantly, but here you can still see loading categories. So this is another perfect opportunity to use Junie to generate a skeleton for us that we can then use directly within a Suspense fallback. So to be able to do that, we can open up Junie by pressing Command-Shift-P or Control-Shift-P and type Junie. And here we can just open up our chat that we had, and we can now continue talking to it and say, do the same thing for, and now we want to do it for the categories, and press enter. I believe it should be able to figure out the context of what we were discussing and just apply the same changes that it did before. Let's see how well it does it. Yep, it's analyzed it, and it created a fallback, and now it should update it right here in real time as we're speaking. There we go, editing the categories, and there it is, the categories fallback, which seems to be like a regular table, but without the data. Perfect. Let's go ahead and check it out in the browser. If I now reload, you can see that as I reload, everything stays the same, and there is an empty table that is just waiting for the data to pop up. Wonderful. The categories table is good, but I don't think it deserves its own PR that's ready to be checked. What we can do instead is also focus on implementing all coins page. Right now, it's a 404, but in the final version of the application, it's going to be another table that'll display the most popular coins. And we can also implement the pagination so you can actually move through this table. Since this is going to be our third table in the row, this is going to be a big challenge that I have for you. More about that in the next lesson. Okay, the coins page, our third table. Is it a bit repetitive? Well, yes and no. Some columns are going to be similar. Sure, we have change, market cap, and volume, similar to what we have here. But at the same time, this table will show hundreds of thousands of coins with proper pagination. By building this table, you'll learn how to handle loads of data without crashing the front end of your application. So let's start doing this together, and if at any point you feel comfortable enough to continue working on this table on your own based off of what we've done so far, I would highly recommend that you try doing that. We have to create a new route. So right within the app folder, we can create a new folder called coins. And then within coins, you can create a new page. That's going to be page.tsx and use RAFCE to generate it. If you've done that, when you head over to all coins, no longer should there be a 404, but rather it should just say page, specifically a coins page. And as I said, this one I want you to do on your own, at least before we get to the pagination part. There's a single CoinGecko endpoint that you can use. This time it's also coming from the API demo reference, and it is under coins list with market data. You can get it by going to coins market, and here you can see the data that you're getting back from it. Your task right now is to display the table for the first, let's say, 10 coins without pagination. So try to put into practice what you've learned so far by reusing this data table, and do the same thing that we have done right here within the categories, where you first fetch the data, not for categories, but for the market list, then display the columns, and then finally feed it all into the table. So pause the video, and I'll provide you with a solution in 3, 2, 1. And here it is. You can ignore these couple of lines. We'll put that to use later on once we implement the pagination. But for now, what you need to do is similar to what you can see on the screen. And if you weren't able to fully do it, I'll provide this file, which is going to be the V1 of the all coins page without pagination so far, within the video kit link down below. So you can copy, follow along, and then we can continue with adding the pagination. So first things first, we're fetching the coin data. We use the fetcher function. We fetch the coin market data array from coins markets. In USD, you can order it if you want to. Later on, we're going to add this pagination, as I said, and then price change percentage, we can leave it to 24 hours. Once you have the data, we need to form the columns. Columns for the rank, it's number 1, 2, 3, and so on. Then for the token image and the symbol. After that, we have the price. We have the 24-hour change as before. And finally, the market cap. Once you have all the columns, you simply feed it into the data, and that is it. Let me know in the comments down below how well were you able to replicate the all coins table from the design of the application. But now together, let's implement pagination. For that, we'll use shadcn pagination. It is simple, yet does everything we need it to do. So let's go ahead and install it by copying this command right here, npx shadcn add latest, add pagination. Then we can also copy its usage. First, all of the imports, which I'll add right at the top. First, we need to copy the imports, and instead of pasting them here, I'll instead create a new component. It'll be called coins pagination. So it's going to be a new file in the components folder called coins pagination.tsx, where you can run rafce and then simply import all the imports, and then also paste the usage right here. And then you can import it within the coins data right here below the data table. That'll be coins pagination, like this. If you now go back, you'll be able to see the demo pagination, which for now doesn't do anything. To be able to make it work, we have to pass some props into it. So right here at the top, I'll say const has more pages to be able to figure out whether a new page exists. For that, we need to get the coins data.length and figure out if that is the equal to per page. So if at one point we get a page that has less than 10 elements, that must mean that there aren't new pages. Then we also need to get the estimated total number of pages. This is done for smart pagination that expands as users navigate further. So we're going to start at 100 pages, add 100 more when users reach page 100, 200, etc. So I'll say const estimated total pages is equal to, and what we can do here is get access to the current page that we're getting from the search params right here at the top. And if it's greater than or equal to 100, we're going to use the math.ceil function to get the current page and divide it by 100, multiply it by 100, plus 100 pages to that, and then divide it by 100. It's a bit of crazy math, I know. So this is the perfect opportunity to use Junie to explain this to us. So I'll say explain this line of code and what it does. simply and quickly. At some point when you're watching a specific tutorial, you can use these chat AI agents not only for productivity, but also for better understanding of the code that you're working on, or the code that I'm showing to you. Because I always try to explain as much as possible, but hey, I cannot directly answer the questions that you might have. So thankfully, Junie can do that. This line of code dynamically calculates an estimated number of total pages for pagination based on the user's current position. Here's the breakdown. If a current page is less than 100, simply returns 100, acts as a default minimum. If current page is higher than 100, then it rounds the current page up to the nearest 100. So if you're in 120, it's going to round it to 200, and then add 100 on top of it as a buffer. And that ensures that the pagination UI always shows more pages without needing to know the total amount coming from the API, which in this case, the API doesn't provide. Basically, it's a sliding window function. So now if we fix that, we can now pass this into the pagination. We'll pass in the current page, set to the current page, as well as the total number of pages. So total pages, pass in the estimated total pages, and finally has more pages equal to has more pages, which we have right here. Now we have to dive into the coins pagination, accept all of these params, and make it actually work. So right here, I will destructure the current page, the total number of pages, and has more pages. And these will be of a type pagination. Here, to paginate, we'll use Next.js's router functionalities. So I'll say const router is equal to use router, coming from Next navigation, not Next router. So be careful here. Since we're using the router, that means that we're using the browser's client-side functionalities. So we have to turn the use client directive on. Then how will we actually paginate? Well, we will paginate by changing the URL of our website. So const handle page change is going to take in the page, which is a number, and it'll simply call the router functionality and push to the corresponding page. So /coins with the parameter of page set to the page that the user wants to paginate to. Then we want to get access to the page numbers, which is going to be equal to build page numbers. And then we pass in the current page and the total number of pages. This build page numbers is a function that I created before. And basically, at any point in time, on whichever page we're on, it's going to give us a couple of pages before and after it, so we can very easily paginate. I'll show you how it works in practice in just a second. And finally, we need to know whether we're on the last page. So if is last page, and that's going to be the case if we have no more pages, or if the current page is equal to the total number of pages that there are. Finally, let's put all of those variables to use by giving this pagination an ID set to the coins pagination. Under the pagination content, we can give it a class name of pagination-content. And now we have the first pagination item, which is going to be a previous item. So give it a pagination control class name, as well as the prev class name. And I'll divide it a bit so you can see what's happening. So we have pagination previous, pagination link, pagination ellipsis, and pagination next. For the previous to work, we have to give it an on click. So here I'll say on click. And what we want to do is take the current page and check whether the current page is greater than 1. If that is the case, we can call the handle page change and pass the current page -1. It is as simple as that. And we can also give it a class name and check whether the current page is set to 1 right now. If it is, then we need to show a control disabled class name. Else, we need to show a control button. That's going to look like this. So now you can see, since we're on page 1, it is disabled. And we can do something very similar for the pagination controls for the next page. So I will simply copy the class name, remove this ellipsis part, And now into the pagination item that is wrapping the pagination next, we can add it, but simply say next. And then I will copy the onClick and the class name functionalities for pagination previous and paste them into pagination next. This time, instead of checking whether we're on the first page, we'll check whether we're not on the last page. So if not last page, then current page +1 instead of -1. And for the class name, if it is last page, then we have to disable it. Perfect. And now finally, we have to display all of the pages in between these buttons. Currently, there's just one, so let's fix that. I'll wrap this in a div that'll have a class name set to pagination-pages. Within these pagination pages, we'll want to map over the page numbers. So take the page numbers and map over them, where we get each individual page and the index for that page. Then, for each one of these pages, we want to display a pagination item. So simply drag it right here. So now you can see many ones, but let's modify it. Since we're mapping over these page numbers, we have to give it a key equal to page. And then we have to figure out whether we're displaying the actual pagination link to the page or ellipsis to show some space in between the pages. So I'll check if page is triple equal to ellipsis. In that case, we want to simply display a span element that will have a class name set to ellipsis, and it'll say ... That's what an ellipsis is. But if that is not the case, then we want to display a pagination link. So here you can see that we have some pages, then some ellipses, and then another page. Of course, these are not all ones. They're the pages that we want to paginate to that we're mapping over. So hopefully now it finally clicked. You're currently on page 1. You can go to 2. You can see that there are 98 more pages in between, and then you can immediately skip to page 100 if you want to. So for this pagination link, let's give it an on click. Set to a callback function where we can handle the page change and pass in the page we want to go to. Then I'll also give it the class name set to CN, and first pass the page link, which is always going to be there. But then we're going to only give it a page link active class if the current page is triple equal to the page that we're on. So now we can see page 1 is active. Perfect. And I think this is it. Like if we now click on page 2, it should actually navigate us and you should be able to see new elements popping up on your homepage. From rank 11 to rank 20, page 2. We can go to page 3, or you can also use these buttons on left and right to simply paginate between these pages. Oh, looks like I got an issue with the pagination item where the key is page. So instead, we can use the key of index instead of the page, because sometimes there can be multiple ellipses in between. If I continue going up, you'll see this. And if I, for example, go to page 100, you can see that now there are more pages in between. So you can immediately jump to 200 and so on. The deeper you go, the more abstract and obscure the coin names and images get. So we'll stick to the page 1 for now. But yeah, I think this is working incredibly well. We now have our all coins table where you can go over all the different coins available on CoinGecko's APIs. The next big part will, of course, be creating the coin details page for each one of these coins. So that when you click on it, you'll be able to see all sorts of different details, such as the price. You'll be able to check it out in all sorts of different currencies, the coin details, a more detailed trend over your chart, where you can update the frequency in seconds, and the price also updates in real time. You'll be able to see the recent trades, the exchange listings, the top gainers and losers, and so much more. But before we get to that, let's actually commit our changes by running git add git commit -m and say implement categories and all coins tables and git push. Of course, we'll need to push it over to the remote repo. and we'll be able to open up a PR and check whether maybe some bugs sneaked in. So let's give CodeRabbit a second, and I'll be right back. And here's the overview. We've added a dedicated coins page with a paginated listing displaying the rank, token information, price, 24-hour price changes, and the market cap. Also the category section. So let's go ahead and see whether we have some issues. Looks like there's one in the coins page where there's an empty link that has no visible or clickable content. This is referring to the rank. So if we head back over here, and yeah, you'll see that the rank itself is definitely not clickable, but the whole row is. So that's totally fine. Like if you click right here, it'll actually lead us to that coins details page. Or if you click here, doesn't matter, the whole row is clickable. So we could actually remove this link because it's not necessary, but thankfully the link is coming from somewhere else. Oh, this one is interesting. It says that there's an edge case. If it's 0% change, then it displays as negative. Rather, a neutral change might warrant a neutral color or no special coloring. This is a good minor suggestion, so we need to explicitly check whether it's trending up or down. If you want to add this change, definitely go for it. And finally, the last one is also thankfully minor, where it says that the alt attribute is set to the coin URL, which is not descriptive. Yep, I agree. Here we definitely could have used the coin name. But for now, since it's just the alt tag, we'll leave it as it is and we'll get back to it later on. So let's go ahead and merge this PR, knowing that we have no major bugs or issues. We can go back to the code, check out over to the main branch by running git checkout main, open up our code on all coins on the main, and then as soon as you run git pull, you'll be able to see what we just implemented. Now, over the next couple of lessons, we'll be diving deep into implementing the coin details page. And this is not going to be just a regular coin details page. I'll tell you more about it in the upcoming lessons. But for now, let's at least create a new branch for it. Git checkout -b feat coin details. And we can get started implementing it. In the next couple of lessons, we'll implement the coin details page. But this is not just a regular page where we display the additional details that you weren't able to see on the homepage. Sure, it does that, but it does it in such a powerful way. If you pay close attention to this price right here, you'll notice that as I'm speaking, the price will change in real time. And so will this graph right here. We'll do it by using CoinGecko's WebSocket API. The goal is to stream in the price, the trades, the candlestick updates, all of that in real time so that the UI feels alive without polling every few seconds. I'm talking about the WebSocket API. If speed of the data matters in any field, it is of course in cryptocurrencies because the price can change so often. So the CoinGecko WebSocket API provides a persistent connection for real-time data streaming, ensuring you get updates immediately. What is important to mention here that we won't be polling the data every minute or every couple of seconds. Rather, it'll really be instant. And the way in which we'll implement it is going to be unique as well. I'll teach you how to create a custom hook. We can do it right away. It's going to be right here within a new folder on our application called hooks. And then within it, we can create a new file called use CoinGecko WebSocket.ts file. This hook will act as a single place that manages the socket connection. It'll be responsible for opening the socket, subscribing to the right channels, handling pings, and translating incoming messages into React state. That means that every component that'll need the live data just consumes the hook and never deals with the raw WebSocket events. CoinGecko's WebSocket API works by opening one connection and then sending JSON commands to subscribe or unsubscribe from channels. In this case, we'll be listening to 3 different channels. One will be the CG simple price, where we can receive real-time updates for tokens as seen on CoinGecko.com. The other one will be the on-chain trade, which will allow us to receive recent trades made on that token. And finally, the on-chain OHLCV, that'll give us the updates that we can then present within our chart. Each channel will send a specific payload, and then the hook will map those payloads into price, trades, and the data for the chart. So let's implement it. We'll start as we start with creating any other custom hook. And that is by creating, well, a hook. Export const use, that is the keyword that makes this function, well, a hook. So we can say use CoinGecko WebSocket, and it'll accept a couple of props like here. For example, we'll need to pass in the coin ID, which is going to be the coin identifier to subscribe to. Then we have to provide the pool ID, which is going to be the on-chain identifier used for trade and candle streams. And finally, we'll need the live interval as well to define how often we want to see the changes. And these are going to be of a type use CoinGecko WebSocket props. And we can also define the return. So right after the props, we can say use CoinGecko WebSocket return so we know what this hook is returning. And then we can open up a function block. That's going to look like this. Within here, we'll first need a reference. So I'll say const ws, which is short for WebSocket, ref, is equal to useRef, which we can import from React. The type of this will be WebSocket or null, because we're going to start this as a null reference. After that, I'll say const subscribed, which is going to be another ref, and this one will track the active channel subscriptions to prevent duplications. So use ref, it'll be a set of strings like this at the start set to a new set. So let me properly close this. There we go. After that, we can create the local state to track the latest price snapshot from the socket so we can display it. So for this, we'll need a use state. It'll be called price, set price, and at the start, it'll be set to null. The type of this price will either be, we can set it to the extended price data or null, since it's null at the start. So let's properly set it to the null value at the start. There we go. After that, we also need a local state for rolling list of recent trades. So I'll create another use state and we'll call it trades. And this will be set to the type of trade array like this. And at the start, it can be set to an empty array. Finally, as I showed you that we'll be using 3 different endpoints, we'll also need 3 different use states to manage the data. The last one will be OHLCV for the Candlestick Chart data. And this will be set to the OHLC data or null. Another start set to null. Finally, we'll need one last use state to denote whether our WebSocket is ready. So is WS ready? And then at the start, we'll simply set it to false. Now I'll open up a new use effect. And within this use effect, we'll have to connect to our WebSocket. It'll have an empty dependency array, so it only executes at the start. So how do we actually connect? Well, we'll need something known as a WebSocket base, which I will define right here at the top. Const ws_base is equal to, I'll turn it into a template string of process.env.next_public_CoinGecko WebSocket URL. If you head over to your process envs, that's going to be env local, you'll see that we don't have an env like that. You'll see that we don't yet have that env, but you can find it very easily by heading over to the CoinGecko documentation. And then at the top of any one of these endpoints that we're going to call, you can see the URL. So simply copy it and add it right here as next public CoinGecko WebSocket URL. So it's WSS and then stream.coingecko.com v1. You can find it directly on the docs. We also need to append our key. So I'll do a question mark x_cg_pro API key is equal to, and now we'll have to pass our process.env.nextPublic CoinGecko API key. And if you take a look, we already have that key right here. Now, there is one important distinction to be made right here. If you head over to the WebSocket beta API page, if you scroll down, you'll see that CoinGecko WebSocket is available for paid plan customers, specifically analyst plan and above. So to continue following along, specifically receiving the real-time updates through a WebSocket, you'll have to go to the API plans and upgrade over to analyst. That way, you're getting all of these WebSocket functionalities. So if you decide to get it, you can continue following along with me implementing WebSockets. But if not, that's totally okay. You can check out the API reference for the demo API and then explore the endpoints right here. I'm leaving this as a challenge to you. You should be able to implement most, if not all, of the functionalities of the coin details page. But the thing is, they won't update in real time. So with that in mind, let's continue connecting to our WebSocket right here. Right within the use effect, I'll say const ws is equal to new WebSocket, to which we have to pass the WebSocket base. Then I'll attach it to our reference by saying wsref.current is set to the WebSocket we just initialized. Then I'll create a small helper function to help us send JSON payloads. Const send is equal to a callback function that accepts a payload, which is going to be of a type record of string and unknown, and it'll simply call the WebSocket dot send function, and it'll stringify the data before we send it, wrapping the payload. So it'll basically serialize payloads, which is a part of the server protocol. Then I'll create another helper called handle message, which is going to handle every incoming message from the socket. So that's going to be equal to an event that comes in of a type message event. Then within it, we'll get access to a message of a type WebSocket message, which is going to be equal to the parsed event data. If the type of the message is ping, in that case, we can use this send functionality to send a type of pong and exit out the function. These are what's known as server keep alive ping messages. As long as we're responding, we're good. We're keeping the connection alive. Now, we want to create a message that we'll receive once we successfully subscribe to specific updates. So I'll say if message.type is set to confirm _ subscription. In that case, we want to extract the channel name from the identifier by saying const channel like this. And we'll get it by parsing the message. So json.parse message $.identifier or an empty string if it doesn't exist. And this will still be a part of the handle message functionality right here. Then we want to record that this channel is now subscribed. So subscribed.current.add channel. Perfect. Now let's also set up the messages for the price updates. These matter the most. So I'll collapse these two ifs, and you can see that we're essentially creating different sorts of function blocks for handling different sorts of messages. So if message.c is triple equal to C1, then this means that this is all about the price. So here we can call our set price state, and we'll have to manually set up all the key value pairs. And this C1 is just a string. So first things first, the USD price. This is going to be message.p, USD price, falling back to 0 if something is missing. So we can do it like this. After that, we'll have the coin, which is going to be the coin identifier. So this is message.I. Then the price itself, the raw price value from the payload, is going to be message.p. Then the change 24 hours is going to be message.pp. Then we'll get the market cap, which is going to be message.m. This is the market capitalization value. The volume 24 hours is going to be message.v, which is the trading volume. And then finally, the timestamp of when it happened, which is going to be message.t. And with that, we are successfully updating the price. One part of the updates is the price, and there are two more, right? Another one is for the trade updates. So I'll say if message.c is triple equal to G2, then here we're getting all the trade updates. I'll form it into a new object, new trade of a type trade is equal to an object where we're getting the price, which is message.pu. Then we get the value, which is message.vo, value over volume. Then we get the timestamp, which is going to be the message.t, which we can set to 0 if it doesn't exist. Type is going to be message.ty, which is going to be buy, sell, or trade indicator. And finally, we have the amount, which is message.to. If you're wondering how I knew that these values would be under these shortened keys, that is coming directly from the docs. So if you head over to the, in this case, we're using, let's see, CG simple price, you should be able to see the data right here. There we go. So this is the data payload. And for the last one, we'll be dealing with the OHLCV data. So if you come here and scroll down, you'll be able to see exactly what we need to get out of it. Okay, so once we get the trades, we actually want to get an array of those trades. So we can simply call set trades to set our state. We get the previous access of the trades, but then we set the new array. So we first add a new trade at the top, then we spread all the previous trades, and then we slice it from 0 to 7 to have a max number of trades. And now finally, let's deal with the most important part, which is the data for the chart. We'll get that data if message.ch is triple equal to G3. This is the channel type. In that case, we can get access to the timestamp, which is coming from message.t. We can see that right here. And if it doesn't exist, I'll set it to 0. Then we want to build the candle in the expected order. So say const candle. Again, that is one piece of data on the chart that is actually combined of multiple pieces of data. So this is of a type OHLC data, and it needs to contain a timestamp for that data. And then after the timestamp, I'll provide message.o, which is going to be the open price, message.h, the high price, message.l, which is going to be the low price, and finally message.c, which is going to be the close price. You can see for these values, it says that type number or undefined is not assignable to type number. So if it doesn't exist, we can just let TypeScript know that it can maybe take a value of 0, like this. And we can wrap all of them within a number converter, so we know that it's going to be a number for a fact, like this. That way we're just getting much more expectable data. Finally, now that we have formed this handle, we want to add it to set OHLCV data, and we can simply pass in the candle. Wonderful. So now we can exit this handle message part because we're handling all sorts of different messages, and we can mark that the socket is ready when the connection opens. So ws.onOpen is equal to a callback function where we set is ws ready to true. Then we attach the message handler to incoming events by saying ws on message is equal to handle message. This is what we worked so hard to create right now to handle all sorts of different messages. We want to mark socket not ready when the connection closes. So that is ws.onClose. We'll say set is ws ready false. And finally, we want to close the socket when the component using this hook unmounts. So I'll say return ws.close. Perfect. So this use effect is managing the connection to our socket, and it's analyzing its responses and giving them to us in a nice, meaningful states in React. And now we want to subscribe to this connection that we created. For that, I'll create another use effect that'll manage the subscriptions. This one will accept a couple of different props in the dependency array. The coin ID, so whenever it changes, we know that we can change the subscription. The pool ID, as well as the is ready, and the live interval. Whenever these change, we also want to recall this use effect. Okay, so with that in mind, first things first is that we got to check whether our WebSocket is ready. That's what we've done in the previous use effect. So if not is ws ready, we simply return or exit out of the function. Then if it's ready, we can actually create a new instance. So ws is equal to wsref.current. And then if no ws, we also return. But at this point, it really should be here. And then I'll copy the helper function that allows us to send these messages from the previous use effect and paste it right here. And now we need to create different functions. Functions for unsubscribing and subscribing to different streams. First, I'll do unsubscribe all. So let's do unsubscribe all is equal to, it's not an asynchronous function. And we simply have to say subscribed.current.for each channel. We simply want to send a new message with a command of unsubscribe and an identifier of JSON.stringify, and then pass in the channel within an object, just like this. Finally, once we are done with unsubscribing for each channel, we can say subscribed.current.clear to clear all the subscriptions. Perfect. So now that we have the function to unsubscribe from all to give us a nice starting point, we can also create a new function to subscribe to a specific channel. So right here, I'll say const subscribe. It's going to be equal to a regular function, but here we have to have some props to know what to subscribe to. So we'll accept a prop of channel of a type string, as well as the data, which is going to be of a type record of string and unknown. Then within it, if subscribed.current.has this specific channel, we simply exit because we're already subscribed. Else, we want to send the command to subscribe. So I'll say command of subscribe with an identifier of JSON.stringify, and we simply pass in the channel. While we're working on this, I'll actually make this full screen so we can see all of the lines a bit better. Then if we also have some data, we can also send another request, this time with a command of message. We also need to pass the identifier to the channel, but now we can also pass the data of JSON stringify data. And this is our function to subscribe to different channels. Now we can invoke a new method called queue_microtask. And here we can provide a callback function where we can reset the local state after the current call stack to avoid mid-render updates. We want to start by clearing the price. So set price to null so that the UI resets when subscriptions change. Then we want to set the trades to be equal to an empty array. We're doing this so the list restarts for a new pool. And we also want to set the OHLCV data to null so the chart resets for the new pool. And finally, we want to remove any existing channel subscriptions before subscribing to new ones. So here we'll call the unsubscribe all function, and then we'll subscribe to the price updates for the selected coin. So we'll use the subscribe to CG simple price by passing the coin ID. So that's going to be coin_ID of an array coin ID with the action of set_tokens. So this is it for queuing those microtasks at the start. Then we want to be able to get all of the recent trades. This is useful for displaying the recent trades in real time right here in the recent trades table. For example, if we go to a coin that has a bit more new information, like let's see, maybe zero base. Yep, looks like here we'll be getting more new trades. Or maybe this Audiera coin, which seems to have many more recent trades that, as you can see, are flowing in real time. This is super cool to see. So for the recent trades, what we can do is we can exit out of the queue microtask. We can set the pool address by getting it the pool ID and replacing the underscores with a colon sign. And then if a pool address exists, then we want to subscribe to it. And we can do that by saying subscribe, pass in the on-chain, but make sure to spell it properly, on-chain trade, and then additional options, such as the network _ID, pool _addresses, and set that to an array of pool address. And finally, provide an action, which is the command to set the pool filter on the channel. So it's going to be set_pools. This is it for subscribing to the on-chain trades. And now just below it, we want to do the same thing to subscribe to the Candlestick Chart data. So I will duplicate this below. I'll subscribe to the on-chain OHLCV. We'll leave the network ID addresses the same. The action will be the same, but here we'll pass an additional piece of info, which is interval, which will simply set to the live interval that we have defined through props. Perfect. So what we have essentially done right here is created one use effect that sets up our WebSocket and makes sure that it is alive. Then we have created another one where we actually connect that WebSocket and subscribe it to all of these different channels for on-chain trades, on-chain candlestick chart data, as well as to get the price. So now that that is done, the only thing remaining from this custom hook to do is to return the data in the simplest format possible. So I'll say return an object that includes the price, the trades, the OHLCV data, as well as the isConnectedState, which is set to isWS_ready. You can see that now our TypeScript is not complaining. We're returning exactly what we need to return, and we're exporting this custom hook ready to be used wherever and whenever we need to access real and live data from the CoinGecko WebSocket API. So in the next lesson, let's use it directly within the coin details page. To start working on the details page, let's head back over to our application right now and click on any of the coins from the coins list. You'll get to a 404, but that's totally fine. What we need to do is create a new route for that page. It's going to be within coins, but then create a new folder within it for a dynamic ID route. To do that, you have to wrap it within a set of square brackets. Then within that ID, you can create a new page.tsx. This is going to be the page within which we'll display our coin details. So if you save it, you should be able to see it right here. But how do we figure out for which coin we're displaying the details for? Well, thankfully for that, Next.js provides us with params. If you do it like this, by turning your page into an asynchronous page and get params, which are going to be of a type next page props, those params will contain whatever you put into this ID, which is going to get populated by the URL. So right now we are on the URL of coins Bitcoin. So we can extract that ID by saying const destructure the ID by saying await params. And then if you say coin details for and then show the ID, you'll be able to see that we're showing the details for Bitcoin. And thankfully, that now very easily allows us to get access to coin details. So right here, we can say const coin data is equal to await fetcher that we have created before. That's going to return the coin details data. And this time, we want to make a call to /coins/ID. We can even provide some additional options, such as the dex_pair_format to be a contract address. We'll use this data soon, but first, let's create a JSX structure to be able to show all of that data. I'll wrap everything into a main tag because we're on a new page with an ID of coin details page. Within it, I'll render a section that has a class name of primary, and then within it, we'll render an H1 that has a class name of text-3XL and font-bold. There, we can say coin, and then we can render it in bold and render the ID of that coin like this. So now we can see coin Bitcoin. This will be replaced with the actual section later on. Then below, we'll display a section of trend overview. Right below it, another one for recent trades. And then below it, another one for exchange listings. All of that is going to be within the primary section. Then we'll have a secondary section with a class name of secondary. And here we can render all the additional coin details, such as an unordered list with a class name of details-grid. And then within here, we need to properly map over the data to be able to display it. Now, the data we're getting from the coin data right here is a bit unstructured, like it has all sorts of different things. So what we want to do instead is only extract the things that we actually need. I'll do that right here by saying const coin details is equal to an array where we can define different objects for different properties. Each one will have a label. The first one can be like market cap, and it'll also have a value. So we can now duplicate this a couple of times for however many key value pairs we'll have. In this case, let's do like 6, and let's at least provide an empty string for the value just so it doesn't break. Now that we have this empty data for coin details, we could map over it right here within a grid. So I'll say coin details.map, where we can extract or destructure the label, the value, the link, and the link text if we got one from each one of these links, as well as the index, and we can automatically return a new list item for each one of these values. But let's make sure that we have properly indented this and that all of the values are in the right place. Here we have the dot map. Within the dot map, we have to have the index as the second parameter. So that's going to go right here. And then we automatically return. Then each one of these LIs will need to have its own unique key, which we can set to index, and a paragraph that'll render the label. So right here, I'll render a p tag with a class name of label, and it'll simply render the label. Immediately, you'll see all the labels say market cap because we haven't yet updated the actual labels. Then below it, we'll check whether it's a link. So if we have a link, in that case, we want to display a div. Else, if it's not a link, we'll simply display a p tag that will render the value. So this p tag will have a class name set to text-base, font-medium, and will render the value. And in the div, if it's a link, we need to actually give it a class name of link. And within it, we want to display a Next.js link with an href going to whatever the link is, with a target of _blank, so it opens it up in a new screen. Within it, we can display the link text, or if that doesn't exist, maybe just the label. And we can also, right below the link, render the arrow up, right, which is coming from Lucid Icons. Give it a size of 16 and close it right here to note that this is actually a clickable link. Also, I almost forgot, right here in the second section, we'll have a currency converter right here. So you can convert a specific cryptocurrency into all sorts of different world's currencies. Then we'll have another div, which we'll use to wrap everything else with. That'll have a class name of details. So make sure to put this h4 and the UL within the details part, like this. And then below that div, but still within the section, we'll render a p tag for the top gainers and losers component. Some of this data coming from the coin details will be static, it'll update on reload, but won't be fetched from the WebSocket. But everything else that we have here, such as the coin price, the trend overview, the chart, the recent trades and exchange listings, the recent trades will be coming from the WebSocket. For now, let's format the coin details data by providing the value to the market cap. That's going to be format currency, which is a utility function we created, where we can get the coin data dot market data dot market cap dot USD, like this. And you can see now the market cap appears right below. Then the second one will be the market cap rank. And this will be just a template string where we use the hash sign to denote the rank. And then we'll render the coin data dot market underscore cap underscore rank. Looks like Bitcoin is number 1 in market cap. Then we'll do total volume, and we can format it properly by saying format currency, and we'll pass in the coin data dot market data dot total volume dot USD. After that, we'll render the website. Some coins have their official coin website. We can get that by providing not a value. Value is just going to be a dash, but rather a link. So the link to the website will be coindata.links.homepage 0. And link text will simply say homepage. After that, we can have another. This one will be for the Explorer, so directly linking to the blockchain site. We'll copy the same structure that we have here, but we will change the link to point to links, blockchain site 0, and the link text will say Explorer. And finally, we have one more. I'll duplicate it here. This one will say community link, or just community. It's going to point to subreddit URL, and we don't have to put the 0 right here. And it'll simply say community. Perfect. So if you save this, you can now see that we have all sorts of these different links and data points that we will structure in a way to look like this: coin details, market cap rank, total volume, website, community link, and so on. Perfect. And now that we've fetched all of this data that doesn't change super often, we can also change the data that we're going to stream in. So right here, still within the same page, at the top of the coin details, right below the coin data, we can fetch the coin OHLC data, which is the data for the candlestick chart. I'll make this equal to await fetcher. It'll be of a type OHLC data, and we can call it by going to /coins, ID, and then /OHLC. We can also pass some additional options, such as the versus currency. That'll be set to USD for now. Then we can also get to the number of days, which is going to be set to 1. The interval, which by default will be set to hourly, and precision, which we can set to full. So now, again, we're doing one call after another, but instead it might make more sense to wrap that all in a promise that all. So I'll say const, we're going to have two different values. The first one is going to be the coin data. The second one is going to be the OHLC data for the candlestick chart. And these are going to be equal to await, promise that all array. And now we simply have to pass the two fetcher functions. The first one, and then the second one after another. And then we can remove the two independent calls, fix this typo right here in the word interval, and I believe that we should be good. Perfect. So now we're getting the coin OHLC data as well. Now, for us to be able to display this data properly, we can create a few more variables that'll help us extract exactly what we need, such as the platform of the coin, which is going to be equal to coin data dot asset underscore platform underscore ID. And if it exists, then we're going to get the coin data dot detail underscore platform question mark dot, and then we're going to destructure within an array the coin data dot asset underscore platform ID. Or if it doesn't exist, the platform will simply be set to null. This is detail platforms. You can see that TypeScript nicely noticed that the platform doesn't exist on the coin data. Then from the platform, we have to figure out which network is it on. So const network is going to be equal to platform question mark dot gecko terminal underscore URL dot split with a /. And we're going to get the third part of the URL split. That's the part that contains the network or null. And finally, from the platform, we can also extract the contract address, which is going to be equal to platform question mark dot contract address. Or if it doesn't exist, I'll set it to null. Now that we get all of that, we also need to get something known as a pool. See, in cryptocurrencies, we need to find the best trading pool for each coin, so the live data can connect to a real market. A pool essentially is a trading market for a token on a decentralized exchange. You can think of it as a pair's liquidity bucket. For example, token USDC, so BTC USD. That's one pair. Within that pool, the trades will happen, and the price and trade data comes from there as well. Essentially, the pool identifies which market the app should subscribe to for real-time updates. So for that reason, you can head over into the CoinGecko.actions.ts, and alongside the fetcher, I've also created another function called getPools that'll make it super simple for us to get access to the most relevant pool. I'll provide this getPools snippet of code within the video kit link down below. Once you add it here, let me explain it. It is just a regular function that we'll use as a utility function, meaning that it'll help us to do something. Then it accepts a couple of props, such as the ID, the network, and the contract address. Both of these are optional. Then we first create a fallback of a type pool data. So each pool will have an ID, an address, a name, and a network, starting as empty. Then if both a network and a contract address exist, we can get the pool data by using the fetcher and a corresponding URL that'll give us access to the pools. Once we get it, we're going to return the first pool. But if we don't have the network and the contract address, we can search for a pool by using on-chain search pools endpoint and pass the query equal to the ID, and then we return it just the same. So now that we have this function, we have everything we need to be able to pass these details into it. So I'll say const pool is equal to await get pools. Okay, this is the utility function we created. And to it, we need to pass the ID, the network, and finally, the contract address. Great. Now that we have this information, we are ready to start fetching real-time data. So let's create a new component right here in the components folder that's going to be called live data wrapper.tsx and run our AFCE. Once you have it, you can head back over here and render it right here at the top of the primary section. Live data wrapper. It'll also accept some children as a prop. So for now, we can just pass an H4 that's going to say exchange listings. And we can remove the rest of the boilerplate code that we had from before, like this. Now, into the live data wrapper, we can provide a couple of props, such as the coin ID, which is going to be equal to ID, the pool ID, set to pool.id. We'll also get the coin, which is going to contain all the coin data, as well as the coin OHLC data, which is going to be equal to the value with the same name. Perfect. And now we can finally get into the live data wrapper component and implement it. It'll make the coin details page feel alive. It's the piece that'll keep the price, the chart, and recent trades, updating them in real time while still showing the rest of the coin info. Without it, the page would only show a snapshot that's already outdated. It also keeps those live parts organized in one place so the page stays clean and it's easy to extend. Within it, to separate those cards or different pieces of text, we'll use a Shatsy and separator component, which is just a super simple blank line basically. So we can go ahead and install it right here within the terminal by running mpx Shatsy and add latest, add separator, and then we can start rendering the JSX. We can start by turning this into a section that'll have an ID of live data wrapper. Within it, for now, we can put some placeholders, like a p tag that's going to act as the coin header. We can then separate it using the separator component coming from components UI with a class name set to divider. Then below it, we'll render another div with a class name set to trend. That'll display the Candlestick Chart. Thankfully, we have already created it so far, and it's not coming from Lucid React. It's actually coming from our own components. And it accepts a coin ID, which we thankfully have because we passed it through the props. So we have to destructure everything that we passed through props right here, the coin ID, the pool ID, the coin, and the coin OHLC data. So let's get it right here. We can destructure them. Make sure to add commas in between. And these are going to be of a type live data props, and I'll put them one next to another. We also get access to the children because right here within the live data wrapper, we're passing something into it. Okay, so now we have the coin ID. What else can we pass into it? We have to pass the data into the Candlestick Chart. So I'll say data is equal to coin OHLC data, just like so. And if you save it, you'll be able to see a chart that we have created so far that'll render the data for this specific coin. In this case, I think it's Bitcoin. Within this Candlestick Chart, we can also render children. In this case, we'll render an H4 that'll say trend overview. The reason why we're repeating this Candlestick Chart here is because we'll make it dynamic and real time on this page. Finally, we'll separate this using a separator with a class name of divider. Then below it, we want to display some recent trades for that coin that we can get access to by using our custom hook. Const destructure the trades by making it equal to the use CoinGecko WebSocket and pass the coin ID and the pool ID. Remember, this is that custom hook that we created before, and we made it accept these things, and it returns the price, and one of those things is the trade. But since we're using useEffect here in this custom hook, we have to give it a use client directive. And if you try to use a custom hook within a server component, that's not gonna work. You have to make that component client rendered as well. So give this one a use client directive. That will give us access to the trades. So now we can render again some columns for the tables where the trades will be rendered. We can call it trade columns of a type data table column, specifically that'll have access to an array of trades, and it'll be equal to, and now once again, for like the fourth time in this course, we need to render the header, the cell class name, as well as the cell, meaning the data that we want to show for each one of these columns in the table. Just so you don't have to type it out by hand, I'll provide you with the final trade columns within the video kit down below. So you can just copy them and paste them here. It'll look something like this. We get the price, then we get the amount, the value, the buy and sell, and the time. And once we have those trade columns, we can simply reuse our existing data table. So below the separator, I'll say if trade columns exist. In that case, render a div that'll have a class name equal to trades, and then render an h4 within it that'll say recent trades, and finally below it render a data table with columns set to trade columns, the data set to trades that we're getting from the webhook, the row key set to, we can get access to the whole row, but also to the index, and then set the key to be equal to the index of the row. And finally, we can set the table class name to trades table, and we can close it right here. It'll look like this, and it looks like in one of these elements, or in a couple, instead of format price, we're gonna say format currency. I believe this should already be done for you. I think I renamed it at one point in time from format price to format currency. So this is gonna be a very simple fix. And you also have to import the time ago. These are coming from utils. It looks like on the day of the recording of this video, Bitcoin had a very positive day. Now, Bitcoin is not a super active token. So it looks like there was one recent trade right here, but it's hard to be able to see recent trades in real time. So instead, we can go to all coins and search for another token. Like I was doing some research, and a couple of times I came up with a token called Audiera. So what we can do is go to localhost 3000 coins Audiera, and this one has a lot of traffic, which means a lot of recent trades. So if you go here, check this out. Without reloading, you can see how new trades are just coming up and changing. So this is pretty cool for traders or for people who really need that instantaneous real-time feedback streaming in through a WebSocket. That makes a huge difference. That regular case where you poll for the updates every minute or so, and when you compare that to streaming the data in, that makes all the difference. I mean, you can see while I was saying this, how many new trades came in. It's instantaneous, live, and without needing to reload or update the page. But this is not it. We'll also make the coin header, including the price, real-time price, as well as the chart, update in real time. So let's do that in the next lesson. So how do we go from this chart that is static and reloads once you, well, reload the screen, to something that updates in real time, either in 1 second or 1 minute intervals? Well, let me show you. We can do that right here within the live data wrapper because as I said, everything will be happening here. So let's add this additional button that we didn't have before for choosing the frequency. I'll create it as a new use state field called live interval and set live interval. And that's going to be of a type either 1 second or 1 minute. So let's do it like this, 1 second or 1 minute, starting with 1 second. And why are we doing this within the live data wrapper and not, for example, within the homepage where we already created the chart or within the chart component? Well, that's because I specifically want the chart on the details page to be live, whereas the one on the homepage is going to be not live. Why? Well, if you later on add user accounts to your application and maybe a subscription package, that would mean that you can charge extra or you can allow users to join your subscription to be able to get real data. Because this is definitely a feature that you can charge money for. If, of course, you want to make both of them live, you can totally do that. So now that we have this live interval, I'll pass it over into the use CoinGecko WebSocket, and it's going to give us back the OHLCV data. We can then use that data and pass it into the chart by passing a couple more properties. So what I'll do is say live OHLCV is going to be set to OHLCV. Mode will be set to live. Initial period will be set to daily. A live interval, is it minutes or seconds, is going to be set to live interval. And set live interval is going to be the setter function that we just created above. So now you can go to the Candlestick chart. We can accept all of these new props, such as the live OHLCV, initially set to null, the mode, which by default will be set to historical, but now we're passing the live mode, the live interval, as well as the set live interval. We're passing these as props. Now, to be able to update it in real time, we'll have to create one additional ref. So I'll do it right here. Const prev OHLC data length. Okay, so we will get access to the length by creating a new ref of a type number, which is going to start as data $.length or 0. That'll allow us to track it and then update it so we can move the chart to show the new candle. Then within fetch data right here, we'll wrap this into a start transition. Start transition means that it's non-blocking for the UI. So it's going to accept a callback function. And within it, we will set the data like this. Then now, since we have access to this set live interval, that means that we need to create a new function that allows us to change the frequency, what I'm doing here. So we can do that right below the fetch OHLC data, handle period change. Oh, but looks like we already created that one. We have it here. So if we choose the same period, it's fine. But else, I'll remove the transition from here since we added it above. And we will set the period to a new period, as well as fetch the new data by passing in the new period. And now within this use effect, we'll have to do some math. So here we're creating our first candle and adding it to a series. Here we'll have to create a new variable called merged of a type OHLC data array. And then if we're tracking the live data, in that case, we want to get access to the live timestamp, which is going to be equal to live 0, like this. Then we need to check if we need to update an existing candle if we're within the same time period. See how right now, I believe this one updated. Yeah, check how it's moving from red to green because we're still within that specific minute. But if a new minute passes, then we need to figure out whether we need to create a new candle. So let's figure that out. Const last historical candle is equal to converted to seconds. Then we need to get the last second. So converted to seconds, that length -1. And then we need to check if last historical candle and last historical candle 0, so the first value of it, is the same as the current timestamp, so live timestamp. In that case, we want to update the last candle with the right data. So I'll say merged is equal to, and then I'll create a new array, spread the converted to seconds data, so converted to seconds, dot slice, So we're going to get the first piece of it from 0 to -1, and then we'll pass the new live OHLCV data. Else, if that is not the case, merged will be simply a new candle. So we can say merged is equal to, we'll spread the converted to seconds data, and we'll append a new live candle. Finally, we're going to exit this else if and create an else right here. If we're not live, merged will be equal to the converted to seconds data, because that's how we've been tracking the data when we weren't live. Finally, we want to sort the candles ascending in time by saying merged.sort A and B, and we take the A0, which is the timestamp, minus B0 to show that we want to render it in an ascending order. And then we can say const converted is equal to convert OHLC data and pass in the merged data. We want to update the candle series ref, but I think we're already doing that here. Oh, wait, it looks like I did it in the wrong use effect. The live updates should have been happening in the second use effect that actually takes a look at the OHLC data. So we need to grab the part that we coded so far. This includes everything up to the converted part, everything with an if right here. So copy that, remove it from here, and instead move it right here within the second use effect. It is this one right here, below the converted to seconds. And then you'll notice that here we don't have to recreate the converted because we already have it, but now we have to pass the merge data right into it instead of the regular candlestick data. Then we do the candle series ref, that set data, converted, and we also have to fit content when the data changes, specifically the period, not on live updates. So I'll check that right here. Const data changed is equal to prev OHLC data length dot current. And if that is not equal to OHLC data dot length, that means that it has changed. And if that is the case, so if data changed, or if mode is set to historical, in that case, we can fit the content for the timescale, what we have been doing here. Let's also close it properly right here. And we also have to update it with the new data. So prev.current is data.length. And here I'm going to add now the data, the period, the live data, as well as the mode. And the only thing we have to do right now is head down to where we have the label. And then below, we can check whether we have the live interval. And if that is the case, then we can render a new div. But let's make sure to close it properly. That has a class name set to button group, within it a span that says update frequency, and we're trying to match something that looks like this, but this is on the finished site. So head over to the current one and to a specific coin, like let's go to Cardano, and here you can now see update frequency, but let's style it a bit by giving it a class name set to text-sm, margin X of 2, font-medium, and text-purple 100/50. Then we can display the buttons, and that's going to be very similar to these period buttons. So I'm going to copy that and just paste it below the span. And these are going to be called live interval buttons. We get the key, we check for the live interval to see which one is currently enabled. And if it is, we give it the button active or not. And for the on click, we want to check whether a set interval function exists. And if it does, we then call set interval and pass in the proper value. Now, if you save this, you'll be able to see the update frequency button appear. And now if you click 1 minute, looks like I get an error saying invalid or unexpected token. Let's see where this set interval is coming from, because it should be coming right here from props. Oh, it's set a live interval, not just set interval. So if we fix this and reload and press 1 minute, okay, looks like it changes, but this coin doesn't make many changes anyway. So we can head back over to the coin that I was on. That is localhost 3000 / coins / Audiera. And here you can see on second that it's really getting updated. But when you switch it over to minute, it's not going to update for a minute and it's going to stay as it is. So now we can also update the frequency and check out the recent trades. It's always super cool to see that happening live. Pretty cool, right? Now, we haven't checked out the whole of the coin details page for quite some time now, and this is how it looks. It looks like we are missing the coin header. The chart is taking the full screen, and then we only have the recent trades and all of the other data, which we have fetched, but it doesn't really look that good. So in the next lesson, we'll focus on making this data look good, and we'll also add a whole other aside to this main content. This is what we want to achieve. Some info about the token changing in real time, then the converter, where we can see what is the value of the token in different currencies. We stay with the trend overview for the live chart, then the coin details, and maybe we even add the top gainers and losers. We'll see. There's also the exchange listing. So there's so much more stuff that we can add to this. Oh, and check this out. Looks like this icon is a GIF, so it actually moves. Some amazing stuff, very dynamic, and it changes in real time. So let's finish the coin details page in the next lesson. In this lesson, we'll display the rest of the information, like the coin header info, the converter, and we'll also style how we're rendering the coin details. Then I might also give you a bit of a challenge to render yet another table, only if you want to display the exchange listings, and also maybe the top gainers and losers if you want to do that as well. But with that in mind, let's dive right in. Back within the code, I'll create a new component within the components folder and call it coin header.tsx and run RAFCE. As soon as you create it, we can import it directly within the live wrapper. We'll do it right here at the top. So instead of this placeholder that we had before, that's going to be the coin header. Perfect. Now into this live data wrapper, we also pass this coin data, but we never used it so far. So now we want to pass it into the coin header to be able to extract the coin information. So I want to say name is equal to coin.name. Then we can get the image, which is going to be coin.image.large. We can also extract the live price, which is going to be price $USD, or if that doesn't exist, it's going to be coin.market_data.current_price.USD. Oh, and the price is coming directly from the use CoinGecko WebSocket. It's one of the 3 things that we're listening for changes on. So that's going to be coming right here from the custom hook that we created. Then after that, we can also show the live price change percentage in the last 24 hours. And that's going to be equal to price $change24. Or if we don't have the live price, it's going to be coin.market_data.price_change percentage 24 in currency .USD. And here we're missing 24H as in hours. Then we want to get the price change percentage in 30 days like this. That's going to be equal to coin.market_data.price change percentage 30 in USD like this. And finally, the price change in 24 hours, which is going to be equal to coin.market_data.price_change_24 in currency.USD. So now we're passing all the necessary coin information to the coin header. So let's simply head over into the coin header and let's get access to all of these prompts that we're passing in. That's going to be the live price change percentage 24-hour. It's going to be the price change percentage 30 days, the name, the image, the live price, and the price change in 24 hours. And all of that is of a type live coin header props. And now that we've got those props, we can also create some new variables that are going to help us later on, such as is trending up. And we can know that if the live price change percentage in 24 hours is greater than 0. In that case, we'll be able to make it green. Same thing for is 30-day up, like this. 30-day up, and price change percentage 30 days is greater than 0. And in general, is price change up, that's going to be price change 24 hours greater than 0. Of course, that's also a new constant that we're creating. And to be able to display the data, we can nicely form it into the array called stats. Each one of these stats will have a label of a type string. Then it'll have a value like live price change percentage 24. Then it'll have the is up, so is it trending up in this case? The formatter that we're going to pass, that's going to be the format percentage function, as well as the show icon. It can either be true or false. So the first one is actually displaying the today value, the price change today. And it looks like we have to import this format percentage from the utils. That's good. And now we can duplicate this 2 more times. The second one is going to be for 30 days. So 30 days. Price change percentage in 30 days is 30-day up and true. And finally, for the last one, we'll show the price change in 24 hours like this. So we can use the price change 24 is price change up, as well as the format price in this case, because it's not a percentage, so format currency, as well as show icon set to false. And make sure to import format currency coming from our utils. So now that we have the stats and we have these variables that we're passing as props, we are ready to render it all within JSX. So first things first, I'll give this div an ID of coin-header, and directly within it, we'll render an H3 that'll just render the coin name. So you can see Audiera right here at the top. Right below it, we can render another div that'll have a class name set to info, and within it, we can render a new image with a source of image of the coin. An alt tag is going to render the name of the coin with a width of about 77 and a height of 77 as well. And you can see the token appear right here. Then within it, we'll render a div that'll have a class name of price-row. And within here, we can render an H1. We'll call the format price or the format currency function and pass in the live price right into it. And if you pay close attention, you might be able to see this number shift from 180 to maybe like 181 or 179. Oh, there we go. It just switched over to 181 without us having to reload the page. And here we can also render a badge. That'll be like a ShadCN badge, so we can just install it. I'll do that right here by running npx ShadCN latest add badge. And we can then import a badge right here at the top and then just use it like so. I'll do it right here below this H1. We'll render a badge with, we don't need a variant in this case, but rather just the class name. That'll be set to CN for class names, badge, and then we can also, depending on whether it's trending up or down, either give it a badge-up or a badge-down class name. Within the badge, we can render the format percentage function, and into it pass the live price change in the last 24 hours. And that's going to look something like this. Minus 24%. Seems like this one is down a lot. We can also, if it's trending up, render the trending up icon. So trending up. Else, we will render, obviously, the trending down icon. And we can just say over 24 hours, like this. So this one went down over the 24-hour period. We can see that very clearly right here. And now we can go below these two divs and render a UL, an unordered list, to show the rest of the stats. So I'll give it a class name of stats, and within it, we'll map over the stats by saying stats.map, where we get each individual stat, and for each one, we just return a list item. This list item will have a key equals to stat.label, and within it, we can return a P that has a class name of label, and it'll simply render the stat.label. So if you save this now, you'll be able to see exactly what I mean. Today, 30 days, price change over the 24 hours. These are the stats that we prepared right here. So now let's also render their values. To do that, we can head over below the speed tag and form the div within which we'll keep track of the values. And let's give it a class name set to cn value. But then also, we're going to give it a text green of 500 if stat.isUp. Else, we're going to give it a text dash red 500 if stat is not up. So I'm simply going to add a not at the top. And then let's display the stat. Directly within this div, I'll render a p tag that's going to say stat.formatter and pass in the stat.value. Okay, so 24%, 117%, and the price change is only minus 0.6 in the last 24, which is actually a lot since the coin value is 1.8. But take a look at this. In the last 30 days, it has actually grown by almost double. So if you thought that this is not good, well, if you take a look at the larger period of time, actually, it's performing incredibly well. And finally, we can show the icon. So stat.show icon. If that is true, then we have another ternary operator, stat.isUp. And if it is up, then we render the trending up arrow like this. Else, we're going to render the trending down icon like so. And we can style them a bit by giving them a width of 16, as well as the height of 16. And you can duplicate those and also add them to the second icon. So it's going to look something like this. Perfect. This is looking so much better. If I make this full screen, it's going to look like this. A bit weird because we're missing something. You can see that we're missing all this outside extra space. And this is a great little design lesson showing you just how important empty space is. It seems like all of this, including the trend overview, the chart, and the coin overview, it needs to be within an additional container to provide that extra space. So let's implement that right away by heading over into our app, Coins ID page right here. First, I have this main with a coin details age. Hopefully you notice this mistake and you have page right here, because when you apply the page, that'll actually apply all the additional padding on the side. And now you'll be able to see that we have the nice coin overview, and also on the right side, the coin details now show up nicely, which for you might have happened a long time ago if you noticed that missing P. Next, we'll implement this converter from which you'll get to know which coin has what amount of value in other currencies. For that, we'll use a SHA-CN select. So if you head over to it, we can just very easily install it by running npx SHA-CN add latest add select. And once you add the select, you'll also need to add the input. So search for, or just command K and search for input. And then you can install the input as well by running npx SHA-CN add latest add input. Once you install them, you'll be able to create a new component called converter. So right here in the components, create a new converter.tsx component and run RAFCE. You can very easily just import it over to your details page, here where we have the placeholder for the converter, and just self-close it right here. Once you do that, if you scroll down, you should be able to see a text that says converter right here. To it, we'll have to pass a couple of things, such as the symbol, which is going to come from the coin data.symbol, the icon coming from coin data dot image dot small, as well as the price list, which is equal to coin data dot market underscore data dot current underscore price. So if you pass all of these three things, you're ready to head over into the converter component, accept these three props, and implement it. So let's just destructure them. The symbol, the icon, and the price list, all of which are of a type converter props, and we can declare a couple of different states that are going to manage the values. First, we need a new use state for the currency that we're currently viewing the exchange rate for, and we can start it with USD. Then another one, use state, that's going to be the amount that we're displaying, at the start set to a string of 10, for example, and then we need to convert it. So I'll say const converted price is equal to, first we'll turn it into a float by saying parse float and pass in the amount, or just 0 like this, and multiply it by price list and then the specific currency that we're trying to exchange to, or 0 once again like this. So that should look something like this. In parentheses, parse float amount, or 0, times price list, or 0. Those zeros might not be necessary, but just to stay on the safe side. And since we're using the use state, we'll have to turn this into a client rendered component. And now we can render the JSX of this converter. So starting with a div that has an ID of converter, then within it, we can render an H4 that'll say converter, and we can also display a symbol. So I'll say symbol dot to uppercase like this. So we know that this is a beat converter, for example. Beat is the symbol for the Audiera, for example, similar to what BTC is for Bitcoin. So if we head over here, Bitcoin, looks like Bitcoin is up 1% in the last 24 hours. And it's so cool to see the price change live. But yeah, if you go here, it says BTC converter. Then we can create an input wrapper. So that's going to be a div with a class name, input-wrapper. And within it, we'll render the input with a type of number, a placeholder of amount, a value of amount, an onChange where we get the event and we can set that amount, and a class name that'll simply be input. So if you save this, you'll have to import the input as a new component that we installed from shadcn. So just say input, and it should auto import it, not from PostCSS, that's a mistake. It should auto import it from components UI input. So now you should be able to see 10. That's the default value that we want to exchange. For example, 10 Bitcoins into USD. That will be a lot. And we can also, below the input, render a div that'll have a class name set to coin info, and within it, an image, source of icon, alt of symbol, width of 20, and height of 20 as well. And below it, we can render a p tag, symbol dot to uppercase. So here we're basically saying 10 BTC. We can also wrap all of that together into something known as a panel. So I'll create another div that has a class name of panel, and then we can wrap this input wrapper that we have here into the panel. So now it's going to appear like a part of something bigger, so we can display another one of these inputs below to show the final result. So now if you go below the coin info and below the input wrapper, here we can create a div with a class name of divider. And then within this div, we can create a self-closing div with a class name of line. And below it, we can render an image with a source of /assets /converter.svg with an alt tag of converter, a width of 32, and a height of 32 as well, with a class name of icon. This is one of those images that we pulled from the start. If you remember, it's going to be within our public and then here, but we just didn't put it within the assets. It's directly within the public folder. So now the icon appears. Now we can go below this divider div and we can create the output wrapper. So a class name of output-wrapper. And here we can render a p tag within which we can format the currency, pass in the converted price to currency and false, and then you'll be able to see the actual number of dollars that 10 Bitcoin is right now. It's almost $1 million. Like if you do 12, you cross that. So maybe you're going to be converting much smaller amount, like 0.1 or 0.01 or something like that. And now we need to make it so that people can see that Bitcoin in their own native currency. For that, we'll have to use the select coming from ShadCN. So head over to ShadCN select, and what you can do is copy this select usage and then paste it right below the p tag. First, we have the select, and on it, you can provide a value of currency, and on value change, you can provide set currency like this. You'll also have to make sure to import all of these things. So I will just copy the imports and add them at the top of this file right here. And then that's going to look something like this. But we don't want to have apples and bananas. What we want to have instead are real world currencies. So to do that, to our select trigger, we can give a class name of select-trigger and a value of currency. For the select value as the placeholder, I'll simply say select and give it a class name of select-value. And we're going to make it not self-closing, and within it pass a currency dot to uppercase. So now it says USD. You can see that right here in the placeholder. And finally, for the select content, we can give it a class name of select-content and data-converter, prop, not a class name. And then we don't need this select group. Rather, directly within here, we'll get access to object.keys of the price list. Then we're going to map over it, get each unique currency code, and for each one of them, return a select item. We'll give it a value of currency code, a key of currency code because they're all unique, hopefully, and a class name of select-item. Then within the select item, you can simply pass the currency code dot to uppercase to display them all right here. Now let's spell this currency code properly because we're mapping over it right here and here. If you do that and scroll down, you'll now be able to see the converter. And if we want to know how much is, for example, 1 Bitcoin in, let's do something like AUD, Australian dollars, you can see that it's 130,000. This means that our converter is working. We can also try in something like rupees, and it's going to be almost 8 million. Now, if you open this up in full screen view, you'll be able to see the beauty of this dynamic real-time coin details page that we just developed. You can change the period, you can update the frequency, you can move around the chart, you can take a look at the coin price in other currencies, you can see the coin details and even the recent trades that impact the price. This is amazing. In the final version of the application, I even took it a step further and implemented the exchange listings so you can see where it is actually being traded, as well as the top gainers and top losers tables. I'm going to leave those two totally up to you. The top gainers is right here in the coin details page at the bottom. So if you don't want to do it, you can simply remove this placeholder and it'll be gone. But if you do, you can try it on your own or just see how I implemented it within the final code of the application. It's available completely for free within the video kit down below. But with that in mind, let's go ahead and commit all the changes that we implemented on this amazing coin details page. I'll open up the code, specifically the terminal, run git status to check on which branch we're on. It looks like we are on the coin details feature, which is great. You can run git add dot, git commit -m, implement coin details real time page, and run git push. We'll of course have to set the upstream to the origin, and as soon as it's out, back on GitHub, you'll be able to compare and open up the new pull request. So let's do just that. And since this was a huge PR, let's see if some bugs sneaked in. Dr. Rabbit, or how I learned to stop worrying and love the code review. Well, let's hope we'll love it after we get back the results. So I'll pause recording right now, and I'll be back in a couple of minutes once we have the complete review, so we can analyze it, so we can make it more scalable and less error prone. In this PR, we added almost 2,000 additional lines of code that result in a new dedicated coin details page displaying market information, introducing live candlestick charts with real-time price updates, and currency converter with the recent trade section showing live market activity. So let's see whether we have some bugs. Within the candlestick chart, there's a potential race condition with concurrent period changes. So if the user rapidly clicks different period buttons, multiple fetch calls can be in flight simultaneously. Since there's no request cancellation, an older request completing after a newer one could override the data with the stale results. Okay, this is actually good. So it suggested using the abort controller. It's a new ref that'll abort any in-flight requests. This is very interesting, and I would say quite an advanced suggestion because it's also using signals. Alongside that one, we also have this little minor issue in the coin header, just saying that the icon is rendered incorrectly when the show icon is false. Why is that? Well, that's because the ternary condition only checks stat.show icon and stat.isUp for the trudy branch. But the else branch unconditionally renders trending down. This means that when show icon is false, like for the price change, the down icon still appears. Okay. And what we should have done instead is wrap the additional ternary within an additional pair of parentheses. That's a good one. So let me immediately find this part in the code. Stat.show icon. Okay. I'll search for it right here. Show icon. There we go. And I will simply replace this part with the new one and remove the plus signs. And now you can see this is a nested ternary. So this one acts on its own and this one is at the start. Then we have the live data wrapper, incorrect fallback for the 24-hour price. When price change is null, the fallback uses this instead of the 24-hour equivalent. This will display the 30-day change when the label says today. So this is on line 53 of the live data wrapper. Oh, this is a mistake. Here, I think we should have used the 24-hour percentage. So let's say price change percentage 24. Okay, this was another great catch because here we're using the 30, but since the variable name was super long, like I wasn't able to see which one I was clicking. So this is definitely super useful. Nice catch. And this isn't even a bug. So I wouldn't fetch this in code, but maybe a user browsing the platform would see an inconsistency and report it to me. But thankfully, CodeRabbit caught it immediately. Then we have one within the use CoinGecko WebSocket. This is a major one. It's missing the on-air handler and the reconnection logic. So connection failures are silent. Okay, so the proposed fix is simply to add the on-air so we know when something happened. So we can head back, go to the use CoinGecko WebSocket, and right here after on close, that's going to be, I think, right here on line 80, we can also check for the error and just add it right here. Perfect. Finally, there is one more here, potential runtime error if pool ID is undefined. So we are using the replace without a null check. So what we need to do instead is simply use the question mark operator to set it to a string if it doesn't exist, so we don't get an error. So let's search for pool ID, and we have to add it right here. Perfect. And the last one is a major potential issue. There's inconsistent error handling between code paths. So the first branch, when network and contract address are provided, lacks error handling and will throw on fetch failure, while the second branch catches errors and returns a fallback. This inconsistency could cause the page to crash when pool data is unavailable for a specific contract. This is entirely true. So what it recommends is also wrapping this one in a try and catch block. So if we head over to the CoinGecko actions and then find that, it's going to be right here. See how we're wrapping this one in a try and catch and then a fallback. We can also do the same with this one. So try here, put all the data there, and then finally do a catch with an error where we can simply return the fallback here as well. Or you could also console log the error or throw it, do anything, but this is going to be more consistent than not having it at all. And with that, we've solved some pretty hard to find bugs and inconsistencies. So I'll go back and simply push the changes by running git add dot, git commit -m, implement code rabbit suggested fixes, and run git push. As soon as it re-updates, we can merge the pull request right into main. Perfect. Great work. Now back within the code, I'll switch over to the main branch and run git pull to see just how far we've come. What you're seeing right here is on the main branch. It looks great. And then don't forget the homepage that we developed not that long ago. The only thing that is remaining is the search modal. So let's talk about that in the next lesson. Up until now, I walked you through every single line of code. From fetching data, building these reusable fetchers, charts, and handling pagination. And while following along is a great way to start, it can trap you in tutorial hell. The state where you feel you understand everything you're watching, but your mind goes blank the moment you open up a blank file on your own. That's why this lesson is different. Instead of giving you the answers immediately, I'm going to give you the requirements and the tools. This simulates a real-world job scenario. A senior developer or a product manager won't give you the code. They'll say something along the lines of, we need a global search feature that opens up when a user presses Command or Control K. Here are the APIs, go. Sometimes they'll even give you a design that looks like this. And very rarely, they'll give you a final working product that you can check out and then replicate. Like what I'm doing right here. That's exactly what you'll do today. Develop a global search feature that opens up when you press Command K and closes, and you'll allow your users to search for any cryptocurrency on the platform. I've created an active lesson that contains all the information you need. The link is in the video kit down in the description. Go open it, study it in details, and try to implement this feature on your own. And if you feel comfortable with that, feel free to help yourself with AI. When you know what you're doing, AI can definitely speed you up. So once again, the link to a special active lesson my team and I prepared for you to implement this feature is down in the description. So pause this video and go and implement it. Because in a couple of seconds, we'll continue with the deployment. We'll do that in 3, 2, 1. Okay, let's go ahead and deploy this project. I hope you did well. First things first, make sure that you pushed all the latest changes. Make sure there aren't any issues. Like for me, when I go to all coins page and then click a coin, looks like I get a console error. I think this is happening on the WebSocket. So if I go here and remove this line right here, it should be good. So I'll just retest it. And there it is. You can push that change if you want to. Then head over to Vercel and log in. At the top, click Add New, choose Project, and you should be able to see CoinPulse somewhere at the top. Import it, and then here you'll see your environment variables. Back within the code, head over into your .env and copy all of these environment variables and just paste them right here. Then click Deploy. This will take about a minute or two, and you should be able to see your crypto application live on the internet where you can share it with your friends and potential employers, as well as maybe some clients that are interested in cryptocurrencies. Oh, and it looks like we have a small TypeScript warning right here that breaks the build. We can fix that very easily by heading over into our next config. And here you can say TypeScript and then say ignore build errors and set that to true. And now we can just do another commit by running git add dot, git commit -m, small fix, and then push. This time on Vercel, you won't have to stay here since the new project was already created. You can get back to your projects, reload, and you should be able to see CoinPulse, where under deployments, a new deployment should be going up right now. Let's see if we get past 24 seconds. And there we go. The build is ready. So back into the overview, click visit to check it out, and take a look at that. We have a final version of our CoinPulse cryptocurrency screener application. We have a price, a beautiful chart, trending coins in top categories. Most importantly, on the coin details page, we have this live price update that just happened. Looks like Bitcoin is a bit volatile right now and looks like it's growing. And you can also modify the frequency of the updates, modify the chart. It's all updating in real time, and it's so amazing to see. And on your end, you'll also have this amazing command or control case search where you can search for any kind of a cryptocurrency and see real updates for it. This was an amazing build. Huge thanks to CoinGecko, not only for sponsoring this video, but for developing such an amazing WebSocket API that allows us to stream in all of this new data without needing to pull it every minute or so. And if you came to the end of this course and you liked it, you'll love what we do on JS Mastery Pro. Specifically for you, I would recommend checking out the Ultimate Next.js course if you haven't already, because we dive so much deeper into all of the under-the-hood Next.js functionalities. So go ahead and check it out, or maybe you want to develop some animations with GSAP, or make your applications more secure by implementing more comprehensive testing coverages. If you want to do that, or just advance your developer career, you can do it all on jsmastery.com. But with that in mind, thank you so much for coming to the end of this course. Amazing job on building this application, and I'll see you in the next one. Have a wonderful day.